Greetings, everyone, and welcome to this day 2 of Pixapalooza. We're so happy to see that so many of you have come back to join us again for this second session of our Pixatope web seminar. And today's topic is going to be augmented reality and you, where we'll be running through how to set up Pixatope for augmented reality, how to set up an augmented reality scene from scratch, as well as all of the different tools and utilities and render modes you can utilize within Pixatope to bring your augmented reality productions to the next level. So, before we move on, my name is still Frank Daniel Moen-Ludvig. I'm a senior product specialist at the Future Group, where I worked for the past 3 or 4 years, traveling the world, helping out quite a few of you on all sorts of different virtual productions. So we are now at Tuesday, which is day 2 of Pixapalooza, which is, again, we are going to be covering AR A to Z before we tomorrow move on to Virtual Studios, and then we'll do a deep dive into the finer details of inputting graphics, inputting data to control these graphics, and building control panels to interact with Pixatope. Now, this is going to be a slightly slower session than yesterday. We are going to take this nice and easy for those of you who might not have substantial Unreal experience. And we are just going to ease our way into actually working with Pixatope from the perspective of someone who might not have used it for that long. We also had quite a few questions come in regarding the Pixatope editor and the Pixatope editor, as well as the Pixatope directory interface, and why I was constantly tabbing between these. It's worth mentioning that typically when you're working on a Pixatope installation, jumping between director and editor, you should typically be using a 2 monitor setup, so you don't have to tab so much back and forth, but instead can have both interfaces up at the same time. I'm sadly using my secondary display for other things right now, which means that I just have to jump between them on the fly. Hopefully it's not too confusing. It's a lot more elegant when you're working by yourself. So we are going to start today with the assumption that we are first going to build a scene completely from scratch, and then we're going to do a deep dive into virtual characters and how we can go about controlling them, just to spice things up a bit towards the end. So of course, we are already looking at an augmented reality scene, which we've already set up, but why don't we go ahead and make a new level just so we can pretend we're doing this from scratch. So I'm going to go ahead and just dive directly into the Pixatope editor. I'm going to navigate to the content browser, and we're just going to create a new folder for us to work in as we make our way through today's session. Generally, when you're just doing sort of R&D or sandbox sessions, we strongly recommend trying to work within your dev folder, which you can, if you're not seeing your developer's content within Unreal or Pixatope, just navigate to the view options in your content browser, enable the show developers content, which will give you access to these personalized folders. I'm just going to go ahead and make a new folder. There we go. And we're just going to go ahead and create a new level that we're going to spend the first half of today's session in. There we go. We also just go ahead and quickly center this. Seems like we gave it a nudge during our setup earlier. There we go. That's a bit too much. There we go, perfect. We're going to save this and we're going to dive straight in. Now, in order to get started with augmented reality, you don't really need a whole lot. You need a Pixatope, of course, as well as a camera feed, ideally a tracking solution, and an augmented reality scene. When you open Pixatope for the first time and create a new level, this is what you are most likely going to be looking at unless you are opening one of our example levels or some of our demo content. You're going to be staring into a block void of an empty level, a blank canvas for us to work in. But notice that, as we talked about yesterday, Pixatope has already gone ahead and spawned these 4 essential actors necessary for our entire pipeline, which means that we don't really have to worry about creating these by hand. We are going to start off by adding our video feed and setting up our tracking, just so we have that covered. So we're just going to go ahead and add, let's see here, we're going to add a calibration cone, just so we have something to work with. Let's actually start by adding a floor. We will center this floor, scale it up a bit. There we go. Let's also go ahead and enable under world settings, ensure that VSUVIG is enabled. If we could change our secondary output to the SDI out. So if you now take a glance at the feed to my right over here, we can see that my SDI output feed is pitch black. The reason for that is because we haven't enabled AR yet, which is the last thing we have to do in the editor. So we'll go to world settings, we'll enable AR, just search for AR and hit the checkbox under picks up AR compositing, enable AR. And the second I click that, we can see that now we are seeing our video being comped in. Very nice. Before we move on in the editor, we are going to go ahead and show how to set up this camera. We are just going to retrace our steps. So we're going to go back into the setup tab of the director. Let me just go ahead and full screen this so we have an easier time seeing what's going on. We're going to go into the setup panel. We are going to assume that we've already managed to, of course, find a project. We've also started a data hub and a camera tracking server. You will not get very far without these. And then we will go to camera. Now we've already gone ahead and set up a green screen camera as well as our augmented reality camera. So for now, we're just going to recreate our AR camera from scratch. There we go. So when you create a new camera, you will just have to click your way through these configuration tabs in sequential order. The first one is going to be tracking. Now, our AR camera is mounted on a MOSYS mechanical tracking system. So we are going to go ahead and enable our mechanical tracking system from this dropdown. It's immediately going to give us a warning telling us that we haven't assigned a tracking server for this particular camera. So we could just go ahead and scroll down to this new AR camera and simply assign a tracking server, which we know is going to receive the correct data. We also need to ensure that the port is set to the correct port. There we go. And we can see here that we can't have two different cameras listening to the same port at the same time, which makes sense. So we just quickly go ahead and shuffle these around. So we see here that the moment we set the correct port and the correct tracking server for this new camera, we are immediately receiving tracking data. Then we just have to go ahead and ensure that all our units are correct, which I know for a fact they are. Our camera is mounted on a tripod and it's a mechanical system, which means that the camera tracking data doesn't tell us anything about how high the camera is above ground. That means we also have to quickly do a camera mount setup for a tripod, which is what we're using. Now we've already gone ahead and measured some of these distances, so we don't have to do this from scratch. So the height of our tripod base or pivot point, which is, if that doesn't make sense to you, then we have a handy diagram on the side explaining what all of these values are, is going to be 118 centimeters. And then I believe these respective values are, I suspect these might be 10 and 15, which is going to be the offsets due to the actual mounting of the camera. And the last thing we have to do is enable a lens file, because again, this is a mechanical track solution, just giving us lens data, but not decoded lens data. So we're going to go ahead and enable this lens file, which is a pretty close match to the physical lens we are using. You also will have to go ahead and set your zoom encoder values and your focus encoder values. In order to do this, we will have to jump into the editor. But before we do that, let's just ensure that we've wrapped up our initial setup with routing video and setting up our video signal. So we go ahead to video IO, and here we can see that our new camera is neatly organized in this list. Due to our default format being set to 1080 50p, that's already selected. We don't have to worry about color space or color profile. We just have to ensure that since we're doing AR, we are not going to be using the chroma key. That's pretty important. We're instead going to input this video feed as a normal camera. And then the last step we have to do is, of course, routing. We already have a video output configured. In case you're wondering how to do that, that's as simple as adding output. You can just call this pixocomp out. Notice that when I killed that, that of course killed my output feed on the side here. So we create an output feed. That's really all there is to it. Under routing, we just have to route our output to spigot 3 and 4 on our Aja Kona 5 card. So our output is going on 3 and 4. This showcases one of the benefits of having this separate routing panel in that I'm able to send a single signal to multiple outputs on the fly. The moment I've disconnected, you can see that our output is back. Next is going to be routing our SDI input. We can see here that we are using the old camera, but we can just go ahead and add the new AR camera. The input for AR is going to the spigot 1, so we have to change this. And just like that, we now wrapped up our setup in Director. At this point, if I were to add, say, a calibration cone, let's just go ahead and add a directional light in our scene from the Modes tab, just so we can see what we're working with. And we can go ahead and hit End. Oh, we might have to ensure this is actually over a solid piece of geometry, and hit End to snap it to the floor. Now, if I were to hit Live, we can see that we have a basic AR scene set up at this point already. And if we are to wiggle the camera, you can see that it's tracking as intended. This is most likely not what you're going to see the first time you set this up for yourself. It's very rare for your video to be in sync with your tracking data off the bat. It's much more likely that you're going to see something like this. So here we can see that our tracking is lagging behind our video. It's very typical to see something like this, or the inverse, that the video is lagging behind your tracking data. And in order to offset for that, you have to go to the Pixotope calibration tab and ensure that you've done your sync. Syncing is the act of offsetting the tracking packets and the video packets by frames to ensure that the correct packets are lined up with each other. So instead of one lagging behind the other, both the tracking and the video is moving in sync. A good way of setting our sync is to either do snap pans or snap zooms, or communicating with the camera operator to ensure he's constantly moving and stopping the camera, while we keep offsetting and adjusting our frames. As you can see, we're dialing this in. And within a few seconds, we now synced up our tracking with our video. Very nice. Now, I do have some finer rotational offsets and location offsets and some lens offsets I need to be using for the camera. So now that we've done the sort of initial configuration, I am going to jump back to our pre-existing AR camera, just so I have some of my finer CCD offsets as well as our rotational offsets existing. These are a bit beyond the scope of today, so we're not going to explain how you would go about setting your CCD offsets, but just rest assured it's something you have the option of doing directly from the Director interface. So to change back to my other camera, all I have to do is jump to my my routing, and I'm just going to change back to the old camera. I'm also just going to go ahead and go to camera and just delete the new camera because I'm not going to be using it. And then I'm going to go to tracking and just reset my port, just because I was trying to use the same tracking on 2 different cameras. So to the correct port, and we're immediately getting our tracking data ticking in. All right, so now that we have our AR scene set up, we can start by doing a bit of a deep dive into what are all the different actors we can use to ensure we get correct reflections, shadows, as well as holdouts. So Sorry about that. So the first thing we have here is our floor, which is always nice to have because you will want to have a floor in AR to catch shadows, also known as a shadow catcher, allowing us to have a virtual object receiving shadows from a virtual talent or a virtual geometry, but that shadow basically being drawn on a real floor. In short, a shadow catcher is something you can think of as an invisible object, and the only thing we render of this object is the shadow it receives. Now, a picture is worth 1,000 words, so I'm just going to go ahead and right-click this plane. This is a completely normal plane. It's not a pixel-specific actor. It's literally just a plane that I dragged out of the Unreal Basic tab. I put it on my floor height relative to my camera, and I just scaled it up a bit. Then I'm just going to go ahead and right-click this plane. Here we can see quite a few different options. We can do all kinds of snapping options, replacing the geometry. We can change the movability, move it to different levels. But what we care about are all these Pixeltop specific buttons. We can convert a plane to foreground, which in AR means that every actor you join will be by default be a foreground object, or basically a standard AR geometry. So foreground basically means it's going to be AR, it's not going to be something else. Translucent is the same as foreground, but it's a custom mode which is reserved for transparent geometries, which has to be treated in our composite in a slightly different way. So if you're doing something like dragging in a glass wall or a glass window, that is something you might want to convert to translucent. We can convert a plane to a VS floor, which is used in a Virtual Studio, so this will be covered tomorrow. We can convert this geometry or any actor to a holdout, which means that instead of being an AR geometry, it's actually going to occlude AR geometry. It's very useful. We typically use this to occlude AR, which is behind certain static fixtures in our scene. For instance, if you have a big crate or a big shape in the center of your studio, like maybe a desk, then you would go ahead and quickly block out the rough shape of the desk in a 3D modeling suite of your choice, import that into Pixeltop, and you can use that as an AR holdout, meaning that you can now put AR behind your desk, even though you don't have a key for the desk. Next up is the AR shadow and reflection catcher, which is what we are going to be using here. We also have an AR light catcher, which is like a shadow catcher, but the opposite. It catches the light caught or cast on the ground or the geometry. And the last we have is the AR ambient occlusion excluder, which is used to mask out ambient occlusion in spots where we might not want to see ambient occlusion. For now, let's just go ahead and enable shadow and reflection catcher. And just like that, we can see that in our composite output. If you just hit play, preview live, we are now casting a shadow. We can see that this shadow is actually clipping through the back wall, which doesn't really look too nice. So let's go ahead and quickly add a shadow catcher for the wall as well. I'm just going to hold Alt, drag up and copy the plane for my shadow catcher. I'm going to rotate it 90 degrees. Let's go ahead and enable snapping for rotation up here, just so we can snap to a nice, clean 90-degree angle. And then what I'm going to do is I'm going to right-click this plane, convert it to foreground, just so I can easily see it in my composite output. And I'm just going to push it back until it looks to me like it's lining up with the far wall. That looks pretty bang on to me. And now if I convert it back to a shadow catcher, we can see that our shadow is now being received correctly by the back wall. I actually seem to have missed a little bit. I was looking at the small output. Let's just nudge that a little bit further. Oh, never mind. That actually probably was pretty bang on. I was just looking at the concave shadow. The way I keep jumping in and out of play mode, by the way, is by using Alt-P, which is the hotkey to jump into play in viewport. So you can see Alt-P to play. And then I just hit escape to go back out of live mode or play in editor mode. So it's very, very simple to jump back in and out to just quickly iterate and look at your graphics. So just like that, we can see that we now have a pretty good shadow catcher. We could, of course, go ahead and add the secondary cube for this little light, the power outlet fixture near the floor. But let's not spend too much time on that because we already have that set up in a scene we're going to be jumping to in a minute. Now, next thing is as we pull this back out here, let's see, let's actually put it somewhere around here. I think that's gonna be nice. This shadow is looking rather overly strong. So I could either adjust my AR shadow from the director underneath production composite. And so you can see here, I can easily offset my shadows. I could also do it from any particular light source within the editor. Just go to details, search for AR, and start offsetting our AR shadow intensity. Or I can offset this exact same value again from the director by selecting the directional light and regulating the intensity of the shadow. So there's quite a few ways of going about doing this. I will use this slider for now. I'm not going to worry about having a perfectly accurate shadow because we'll be spending more time on lighting in a bit. For now, we're just going to dim it so it's not as distracting. And we're going to go ahead and add some reflections now that we've gone ahead and added our shadow catcher. We can of course see here that we have a pretty ruggedy carpet floor, which means that it shouldn't be receiving reflections. There's no point of reflecting AR here. But just so we've looked at it, we are just going to use a bit of suspension of disbelief and pretend that the floor is a perfectly mirror surface, meaning that we need a perfectly mirror reflection. There's many ways of going about doing this. We can use screen space reflections, we can use planar reflections, or we can use ray traced reflections. The easiest way to go about enabling this is first to go to world settings, search for reflection, and ensure that enable reflections is turned on. Then we are going to select the material for the floor, or we can just create a new material, shiny floor. The only thing we're going to be doing this material is ensuring that it's pretty shiny by setting its roughness to 0. That looks pretty shiny to me. We're going to go ahead and save that and put that on our floor. Now, just like that, we can see that we are now we're now casting a reflection onto the floor. But we might also realize that we're actually reflecting our backdrop here, or our invisible shadow catcher on the far side. The reason for this is that I believe we are currently looking at ray trace reflections. Let me see if we have ray tracing enabled. Yes, that's definitely ray trace reflections, which means I will have to go ahead into the material for the back wall and exclude it from ray tracing. Let's see here. Now, I don't quite remember exactly where I'm going to plug this in, so I'm just going to quickly look at the reference material just so I'm sure I'm plugging this in the correct spot. So I'm doing is I'm looking at another material we have prepared just to ensure that I'm connecting this quality switch in the correct place. That's going to be into opacity mask. Okay. So this useful little utility will allow us to disable a material from showing up in ray trace reflections. I'm going to go ahead and ensure that this is set to mask translucency. And we're going to go ahead and set that to be a 0. There we go. We're going to go ahead. So all we've done is we set this ray tracing quality switch to be 0. We're going to go ahead and save this. And just like that, the shadow catcher for the far wall is no longer casting, it will be showing up in our ray trace reflections. We actually probably do need that to show up in normal, not in ray traced. So I'm going to input a 1 here under the normal config, just to ensure it's still able to receive shadows. Ray traced reflections and shadows is of course the best you can possibly have, but it's also the most expensive form of reflections. But we can see here that if we move the camera around a little bit, we can see that this is a perfect reflection. Now, we can easily offset and adjust this reflection in a multitude of ways. We could, for instance, go into our world settings and simply pull down the intensity of our reflections as well as our reflection alpha, just to dim them down a bit. And this will, of course, give you a weaker reflection. We can also break up our reflection in a multitude of ways, simply by giving the reflection catcher a bumpy material, or basically a normal map, allowing it to start scattering the reflection the same way any other material in Unreal works. So here I can go ahead and select my floor. We're going to adjust the material that we created for it, the shiny floor. And we are just going to find a normal map for it. I believe I have a detailed normal map here, which we can go ahead and plug directly into the normal input of the shader. If anything here is unclear or if I'm going too fast, please do not hesitate to ask questions. We will be going through all questions at the end of this session, and we'll be answering anything that was not covered in a satisfactory way. So you can see here, simply by inputting this normal map, we now started scattering our reflection. Can we possibly tilt the camera down a bit? Just unlock it, tilt it down, and lock it again. While he's doing that, we can see that this scattering is a bit too large scale. It almost looks like an artifact. But not to worry, we can just dive directly back into our material. And we can just apply a multiplier to the UVs of this texture. So instead of having it stretched out across the entire floor, we're just going to tile it multiple times. We are simply going to hold the U button to get a texture coordinate or UV node. And we're just going to hold M to multiply this with basically how many times we wish to tile it. If you multiply texture coordinate by 2, that means instead of drawing the normal map once, we're going to tile it 2 times, so 2 by 2 across this plane. Or in this situation, we might tile it up to 50 times, just so we get some sort of smaller grungy details in our reflections. You can see that immediately in this little tooltip here, we can see the tiling has been applied. And the moment I save it, we can see that we now have a much more coarse breakup. We can then also further on go ahead and flatten this normal a bit using the flatten normal node within Unreal, which simply allows us to squash the normal so it's not as strong. I just right click here, promoting flatness to a parameter, just so I can easily give it a value on the fly. I'm going to actually flatten it 95%, 1 being fully flat, so 95 being very flat, just so we have a hint of a breakup and a hint of distortion. Very nice. And then we could, of course, build on this. We could start affecting our reflection with Fresnel nodes. So we only have reflection at sharp angles, which is matching the physical properties of a lot of shiny surfaces in the real world. We could do things like taking in our video feed and actually generating a normal map from the video feed to ensure that the reflection on the reflection breakups is based on what we're seeing in the physical video feed. And you can take this as far as you like. But I think the general idea gets across. So I think for now we can move on. When it comes to reflections, the one we tend to use the most is the planar reflections. If, let's say, you don't have ray tracing active, or your scene or your virtual set is too heavy to use ray tracing, we're just going to quickly disable ray tracing using my RTX toggle here. So here, if I now access this blueprint we made earlier, This little blueprint is a widget that I just cooked up to quickly execute a large amount of console commands every time I click this button. You see there's a event or trigger connected to a flip-flop. A flip-flop is like a light switch. Every time you click it, it just flips to the different output, A and B. At the top row, we have a lot of console commands, like R ray tracing ambient occlusion 0, ray tracing reflection 0, shadow 0, and so on, basically forcefully turning ray tracing off. And these console commands at the bottom just turns ray tracing back on. So toggling this, we should now not be seeing ray trace reflections. Hitting Control-Shift-Comma to bring up my debug, it shows that we're still receiving ray trace reflections for some reason. So let's go into console and just try to forcefully kill our reflections. Okay, so this seems to possibly be ignored for our reflection pass, but not to worry, we can easily jump out of our editor. We can go to the Setup tab in Director under General, just disable DX12 mode, and now we've forcefully disabled ray tracing. Now I did forget what I named the level. This is why good naming conventions are important. It is, you know what? It's probably not going to show up here because I put it in my dev folder. One of the benefits of using a dev folder is that the contents of the folder will be, generally speaking, be ignored, meaning in search and when you look filtering for assets, meaning that if you have a dangerous experimental asset in your dev folder, you're not going to risk someone accidentally using it in a production level. So we're going to go into session 2 here from sketch level, and we are back where we left off, but this time with no reflections. The other way we can go about adding reflections is using screen space reflections. This is a very cheap way of doing reflections. It's very performance efficient. It is also my least favorite form of reflection for a few different reasons. To enable that, we're going to select our post-process handler. We're going to go to details. Now we're just going to search for screen space reflections and ensure that this is enabled. So first of all, using screen space reflections, we can see that again, our backplane shows up. And this time we have no efficient or meaningful way of filtering this out, which meaning that either we have to not be using the backplane, or we are going to have a very bad time in terms of getting a clean reflection in AR. Another issue with screen space reflections is that they can only reflect what you're seeing on your screen, which means that could you possibly zoom in on the reflection? So notice now as our camera operator Magnus tilts on down and zooms in on the reflection, the moment the top of the cone exits the frame, keep going, zoom in, the reflection goes away as well, causing all kinds of nasty ghosting and halo effects, especially near the edges of our frame. So you can see there at the bottom, it looks like the cone is shrinking, which just doesn't look very nice. To really highlight this issue, we can go ahead and pull in a more complex geometry like a character. This is also going to be a sneak peek at the characters we are going to be playing with towards the end of our session. Courtesy of Epic, we've decided to use some of their Paragon game assets, which you can freely grab from the Unreal Marketplace, in order to mess around with some virtual characters and gorgeous photorealistic game-ready as assets. So you can see here that the reflection for our character is missing its head, and as we zoom in on that reflection, we start eroding more and more. If you also pan to the left, just pan so the character is towards the edge of the frame, just keep going, all the way, keep going. As we approach the edge, keep going. We also start eroding from the side. I believe we can't actually pan anymore because the camera is crashing into a physical monitor, but I'm sure we've looked enough at this. I'm not saying you shouldn't be using screen space, but just make sure you are aware of the limitations. Now, what you could do is you could do something like using screen space reflections in conjunction with another model called planar reflections. So we can go ahead and go to the Modes tab, and we're going to add a planar reflection actor in our scene on the floor. The planar reflection actor is something you can think of as a giant mirror. It is basically a giant plane, and what the plane does is it takes your graphics, all your polygons, all your models, and it flips it across the plane using the plane as an axis in order to draw a physically correct reflection. This reflection will still be distorted by the roughness and the normal maps of the surfaces which we are reflecting across, meaning that we'll be getting a far more accurate reflection. Now, this is a bit messy with both screen space and planar visible at once, so I'm just going to go ahead and turn off screen space to ensure we are now only looking at planar reflections. You can just go ahead and wiggle this a bit, zoom in on the reflection. So you can see that this is, first of all, a much sharper reflection. We can also see that the reflection are not being eroded in the same way, so it's much more precise, much more lovely to look at. Now, by hitting Ctrl-Shift-, to bring up my single frame analytics, we can, however, see that using a single planar reflection plane is using almost half of my total render time. Planar reflections are very heavy, so keep that in mind if you decide to utilize them. However, they can be optimized by simply scrolling down in the planar reflection actor. And here in the scene capture, we can choose to only capture or only reflect certain actors, which is very relevant if you're doing AR. So instead of reflecting everything, I will just go ahead and use a show only list. And I'm going to go ahead and only reflect this character. So I'm going to add an element to the show only list. We're going to use this eye picker tool to choose our character. And now if we preview this and use the same test, we can see that the cost has gone slightly down. It's not by a whole lot because there wasn't really a lot of other things in the scene in the first place. But we could, of course, take this even further and start removing certain render flags from our reflections. We could do things like removing lighting or dynamic shadows from reflections, which would optimize our reflections even further. So you have very granular control. If you expand under scene capture, you have all these different show flags, allowing you to turn off certain attributes from being reflected, like for instance, dynamic shadows, which is going to make a slight difference. As you can see, we are losing the shadows under Sparrow's arm and between her legs. But this will also greatly improve the overall performance of your planar reflection. Okay, so that's enough about reflections. When you start having a more complex scene, when you're using all kinds of shadow catchers and AR objects and holdouts and so on and so forth, if you're wondering what any particular actor is converted to or assigned as, you can select any actor, go to the Details tab and search for Stencil, which is going to tell you what the current custom depth stencil value of that actor is. Whenever you right-click and convert an actor to any of these different types, what we're actually doing under the hood is simply changing this custom depth stencil value. Some of these might also change things like shaders and material attributes, but this is the main identifier telling you what the purpose of any given actor is at any given time. So you can see here that 1 is the default AR object, whereas the shadow catcher on the floor is 2. I don't remember the other ones off the top of my head, and neither should you have to. Just know that you can go in here if you're interested in seeing what a current actor is assigned as. You can also, if you start having a very complex scenes with tons of actors and you just want to see a quick overview of the different buffers showing what's actually happening in a composite pipeline, we can go to world settings and we can, under visualization mode, visualize any given buffer which is being utilized in our composite pipeline. We could, for instance, go ahead to AR effects buffer. Wait, let's see here. That's actually not the one I want. We are going to want the reflection buffer. Now in our output, we can see our final, just our reflection buffer used in AR. Could I possibly pass you minus to just ensure I have my return feed up and running? Thank you. These are, again, not really meant to be used too much by standard users, but if you're curious about kind of what's happening in different buffers, this is where you can go ahead and have a little peek around. Here, for instance, under VS Alpha, we can see our shadow catchers in the blue channel of this particular buffer. All right. Now that we've covered the shadow catcher and how to enable reflections, the last major attribute we need to cover is holdouts. So I'm sorry because you just sat down, but could we possibly get in those handy boxes as well? Because here we have, of course, an AR character, as you can see. But what happens if I wish to have this character behind a physical object like these boxes, which my colleague Magnus is putting on the ground? Let's just go ahead and disable reflections because they are very distracting to look at, given that the floor is not reflective. There we go. We can also see that we have, looking at these boxes, we can see that we actually have two concurrent shadows being cast. We have this shadow coming diagonally from the left, cast by the left spotlight, and we have another light source casting shadow towards this left-hand side here, which is much weaker. We're going to line that up more correctly in a second, but for now I'm just quickly going to use two directional lights just so we have some roughly matching shadows to look at. Let's go ahead and what I'm doing is I'm taking my directional light source. I'm just going to copy it just so we have shadows being cast in two different directions. It's also a bit strong, so let's just go ahead and dip them down a bit. Very nice. Let's see. Let's go ahead and actually drag in a few other static meshes as well. Let's just filter by static mesh just to populate the scene a bit. It's a bit lifeless and dull in here. I am getting a rather bad case of cabin fever due to the stay-at-home order. So I'm just going to add a few different pieces of foliage just to pretty up the scene a bit. There we go. It always looks nicer with a little bit of greenery. That's a bit big. Let's scale this down. You don't really need this calibration cone, so let's get rid of this. I believe I also had some rather good looking rocks. If you're looking for where to find assets like this that you can use in all of your productions, we would like to point your attention towards the fact that pretty much the entire Quixel Megascan library has, courtesy of Epic, been made freely available for anyone to use in their productions after Unreal 4.23 came out. A lot of these assets which we're currently using are sourced from that very library. There we go. So now this is all looking rather nice and lovely, except for the fact that we have some air elements which are not sorting correctly. We have these rocks and some of this foliage which is sorting in front of our boxes when it looks like they should be behind. And we also have this little bush underneath our chair which is being drawn on top, which just simply doesn't look that nice. Let's just tuck this in over here. Let's move these in. It's also not nice just seeing a character in a static T-pose. So I'm just going to go ahead and select my character and just give her an idle animation to just loop in the background. There we go. So holdouts. I'm getting a bit carried away with the creative process. Let's try to get back on track here. These boxes on the floor are a good use case because they're going to be very easy to reconstruct. I happen to know for a fact that they are 20 centimeters across, which means I can, as a holdout, all I have to do is add a cube which is scaled by 2.2. The standard Unreal cube actor is 1 by 1 by 1 meter. So if I want 20 centimeters, I will just have to go ahead and scale it to 0.2. I'll just go hit N to drop it on the ground. And I'm just going to be using my reference monitor on the side here to quickly line this up with the physical box on the floor. I'll turn off snapping because I need to have a little bit more control. There we go. That's my first box. We are going to build a bit of a tower here. So let's just quickly get all of this out of the way so we can see what we're doing. I'm not deleting these, I'm just hitting the eyeball in the world outliner to ensure I'm able to hide these objects. Then we're going to set the box on top. Let's hide the one below, so we're only working with one at a time. Coming to think of it, I guess these are not actually, strictly speaking, 0.2, they're actually 19 centimeters. Holdouts should be as accurate and precise as possible. When you are generating holdouts for much more complex shapes, like for instance the chair in the background, you might want to be using photogrammetry or other types of scan data to ensure that you have a 3D model which matches your physical geometry or real-world object as close as humanly possible, simply because it's going to give you a much nicer looking result in your final output. It's pretty close. It doesn't have to be perfect for demo purposes. I mean, ideally it should, but we are also on the clock here. So we're just going to go ahead and add a single one on our tower of blocks here. The government is encouraging all of us to stay inside and play more computer games. So I'm guessing this is the closest I'm going to get. There we go. Now that we have our stat cubes, we can just go ahead and put these in a folder called Cube Tower Holdout. It's always good to be a bit orderly in your projects, try to organize things and keep things clean. Otherwise, you might quickly end up with a bit of a mess. I'm also going to put all of these in a new folder called Foliage. Very nice. And I'm going to go ahead and take my cube tower, hit Control G to group it. You can also right click the actors and go to groups to group them. Grouping just means when you select one, you select all of them, which is handy when you have collections of actors you want to keep together. Last thing is I need to do is right click and convert to holdout. The moment I do that and re-enable my foliage, we can now see that using this holdout, we are able to sort these cubes in front of our geometry. We can, in order to understand what's actually happening here, I can actually decouple from my tracked camera using F8 on my keyboard, allowing me to fly around and see what's actually happening. So you can see we actually have these cubes which we are projecting video onto. There's also, technically speaking, being projected on the floor behind it from the point of view of the tracked camera over here somewhere. So all the shadow catchers and holdouts are simply receiving the projected video, and from the point of view of our tracked camera, this is always going to look correct. We can also see that our top cube is a bit off. We're seeing a 1 pixel halo off to the side. We could, of course, ignore it, or we could spend 2 seconds just making it look a little bit more bang on. There we go, much nicer. I'm doing this for my artist friends out there in the audience who I'm certain caught this immediately popped up on the screen. There we go. For the chair over there, we can of course not solve that with simply a cube. Luckily, in order for this session to not be too long, we've gone ahead and already created holdout geometry for that particular chair. Now we do have 2 very similar chairs here, so let me just ensure I'm getting in the correct one here. Is it S chair TFG or S chair TFG? I'm going to go on a wild gamble. Oh, I'm not going to do that. I'm going to go on a gamble and assume it's going to be this one because they do seem very similar. And I'm just going to go ahead and slide this into position of the actual chair. So this chair has been made using photogrammetry in order to get it to be the more or less the exact same shape as the orange chair we're seeing here in our studio. This can be a bit of a labor-intensive process, but it is absolutely worth doing in order to ensure that you're bringing your AR production to the next level by having your augmented reality objects being occluded by and casting correct shadows on physical geometries. These are the smaller details that really help sell your AR productions. It's all of these little bits and pieces that really in the end adds up. You can see that the position is probably a bit off due to the top brim, but given that I'm just trying to occlude this bit of foliage under the chair, let's actually go ahead and add a little bit more, just holding Alt and just moving this around. There we go. We can even have some which is partially intersecting this chair leg. And then when we jump into play mode, oh, we're still seeing the chair because of course, sorry, I need to slow down a bit. We're still seeing the chair because I didn't convert it to a shadow catcher. We could use a shadow catcher to receive shadows, or we could just convert it to a holdout. I think here I will just go ahead and convert it to a holdout, no, actually to a shadow catcher, because we might want to be able to receive shadows on this chair as well. For instance, if we have, let's say we have a virtual chair directly next to our physical chair, and we want some shadows to bleed across, like so. Of course, we won't be seeing the shadows from this angle. Let's actually shuffle this chair over here. Let's put a bit in front. And now if I could possibly pester my operator to zoom in on the flowers there a bit, we can see that we have lovely lush AR foliage tucked underneath the chair, being correctly occluded by the chair geometry. Now, our lens distortion calibration for this particular lens is a bit off. So as we move the camera, we can see it drift a little bit. That's simply because we need to spend more time calibrating this camera. We're in a bit of a hurry getting our studios up and running and bang on. But if you were to leave this at this angle, just leave the camera, lock it, then I can quickly go ahead and really fine tune this from this particular angle. I'm just going to again right click, convert this to foreground geometry. It's a bit hard to see what I'm doing with all this foliage, so I'm just going to go ahead and hide all of this. There we go. Now that we're back in live, we can see that we have a much more bang on occlusion and shadow catcher. And the cool thing here is now I could do something like, let's say, put a virtual character sitting in this chair, for instance, our lovely mascot Dot. Now, I forgot what we call this blueprint, so I'm just going to filter by blueprint classes. There we see Dot sitting and waving. I can simply take this character, put him in the chair. And as you can see, he's actually casting shadows onto the physical chair. Without a shadow catcher based on the physical geometry of the chair, this is not possible. The only reason we're able to do this is because we've spent the time, we spent the effort to ensure we have geometry matching the geometries of the physical set. Even you see that the armrest at the side, it's even lining up correctly. Now, we could spend a bunch of time lining them up correctly, but I think it's time for us to move on. So we talked a lot about these sort of more simple geometries and the general use cases for using shadow catchers and holdouts. But if we are using ray tracing, there's another more important use case for these geometries as well. Because with ray tracing, we could reconstruct our set as an invisible reflection geometry within Pixeltope and use that to cast physically accurate reflections onto our AR as the AR moves around the scene. And we will look at what this means right now by just jumping to this different slide tab. So courtesy of my dear colleague Øystein Larsen, who's happily sat down and written up a step-by-step guide on how to create these holdouts and creating these sort of studio doubles, we can now see how this is done step by step. There's two steps of this. There's of course the generation of the geometry, but we also wish to capture the actual color data and basically the reflected data of the physical set. This is known as generating a cube map or doing an HDRI capture. The way we generally tend to do this is using a Ricoh Theta, which looks like this. It's a very nice, very small portable 360 camera. There's quite a few different models. I personally like the cheaper ones, so I feel less guilty if I were to break one during travel or on-site. But they are very affordable, very powerful 360 cameras, which we always bring with us to all the productions we help out at. You can simply power it on. We can do a quick 360 capture at the push of a button, either using the device directly or through our phone, so we can do a 360 capture when we're safely out of the frame. So we are now going to look through how we will use this camera to generate a cube map, and by doing multiple exposure captures, combining that to a single HDR, and then reconstructing our set geometry and projecting our capture onto this geometry. This is useful in short to summarize, for correct shadows, correct reflections, as well as having a correct holdout geometry, allowing us to layer AR in front or behind physical shapes. Yes, and specifically for RTX, it also allows physically correct reflections and lighting. There's quite a few different models. The Ricoh Theta newest one also allows, the newer models allow shooting raw images, as well as all the way up to 5K 360 images. You can never really have too much resolution in your 360 captures, so that's a very huge benefit. The cameras we use, we generally have to do multiple stops because they are not HDR by nature. So we tend to do 8 to 10 different exposures with a few stops of difference. It's also important to make sure you have a paper card or a whiteboard to ensure you're able to set your white balance. So here we can see the actual images we took from our physical set 2 days ago. We bring these into Photoshop and set the white balance across all our different captures. Then we go ahead, and in Photoshop there's a very useful utility called Merge to HDR Pro, which is located underneath File Automate, where we simply dump in all our images and we allow Photoshop to sort these for us by automatically aligning the source images based on the data within the image itself. And the next step is critical that you ensure that you enabled 32 bits, otherwise you will not be able to export this as a Radiance HDR image and use it as a cube map. And then you can move forwards and complete your final toning and fine adjustments within the ACR. When you are done, you can go ahead and adjust the image, adjust the exposure to better set your mid-exposure level to just ensure you have a nicely balanced 360 capture. You definitely should go ahead and clone paint out any unwanted shapes or geometries within your capture. We can see here the white paper tucked away between the power fixture at the wall. We can also see the tripod at the bottom of our cube map. Go ahead and use the clone stamp tool to paint this out. When you're done, just resize to a 4K image and export it as a Radiance HDR, which is now ready to be imported into Pixeltope and used as a cube map. You can keep the original for sphere, so you have all the pixels, all your raw data. If you wish to take this to the next step and do a spherical projection within a 3D modeling suite, which then can be used for physically correct ray trace reflections. So here we can see within Maya, I just went ahead and recreated the large primary shapes within the studio. This can also be automated by using something like a LiDAR scanner to just give us a automatically generated 3D model based on 3D scan data. Then the next step is simply projecting our 360 capture onto these unwrapped final geometries. Make sure they have decent UVs. And when you have here like these lighting fixtures in the backdrop, you can see that we have a separate geometry for a lighting fixture, which means that we probably don't want to also have the lighting fixture in the texture on the ceiling. So you can go ahead and clone stamp out artifacts like that as well. Now, when we are done with this, we can pull this into Unreal. The benefit here is that we can see that as we move a very shiny AR object around, the reflections on this chrome ball in this particular instance looks correct based on what's happening in the scene around it. You can see here we have the physical lamp, and as the chrome ball moves closer, the reflection becomes bigger. And inversely, this chrome ball over here, as it moves towards this darker corner, we can see the floor reflected correctly, and we can also see this billboard on the side becoming bigger the closer we pull the chrome ball. Just to compare, this is using this method where we've gone through the headache of setting up this sort of studio double with ray tracing, and this is without. We can really see that the proximity details, like the orange from the chair as the chrome balls come close, completely disappears when we are just using a standard cube map to give us reflections, because the standard cube map is the same as saying I have an infinitely huge sphere which has the cube map applied to it, and that's what I'm projecting onto my geometries. Here we can see that no matter where these chrome balls are located, the reflections are always coming from the same directions, which in extreme cases is completely off. This chrome ball is reflecting the chair as if it was below, and this one is not really reflecting the chair from the direct angle and is far too small. Same thing on the right-hand side, we're not really seeing the banner reflected in any meaningful way. With ray tracing, it really brings these reflections to where we would want them and where we expect them to be in a state-of-the-art virtual production solution. It's also worth mentioning that we can actually jump into the set and look at this in person. Let's just go ahead and save this scene. Let's see if I can find this level. Let's just disable all the filters. And if we jump into this RTX stream, we can actually see these geometries that we just were talking about. Just going to go ahead and pull in a chrome ball. Let's not scale it, let's just pull it in. Let's see if I have a chrome material, so we have something that is perfectly reflective. And then let's also go ahead and ensure that we have ray tracing enabled, because I did just turn it off under our general settings. We'll turn ray tracing back on, and we'll just go ahead and jump directly back into this level. There we go. So again, we pull in a sphere, we give it a chrome ball surface, and we can immediately see the difference in that we now have our reflections. As we just talked about, we can quickly move this around and we can see the reflections change due to the fact that it's getting physically moving closer to these different geometries. And we can also see, even more interestingly, if we are using say an HDR pipeline. Just go ahead and get rid of that text overlay. If you're using an HDR pipeline, given the fact that our images are EXRs with high dynamic range, as we really pull the exposure, we can see that we have the full range from our HDR available within Pixeltope. Very nice. Okay, so let's jump back into our development level, and we can move on. And the next step, once you have this geometry, is of course we have the same material parameter that we just used. The ray tracing quality switch replace will allow you to make these Studio Double invisible to naked eye, but still show up in your ray traced reflections, which is how you would be going about using this in your final AR scene. All right. So to summarize, with ray tracing, we now have access to the tools and methods that allow us to really integrate our digital AR elements well within our physical sets. The better you sample and apply the real world, then of course the better your output is going to be and the more real your digital creations will become. And all of this in real time at a very comfortable frame rate. All right, very cool stuff. Now we're going to dive back into our scene. And let's see here, we've looked at reflections. We also looked at most of these different modes. We can now jump into a scene which already has a bit more stuff set up. In this case, we are just going to jump into our backdrop scene where we've already measured up and aligned some light sources. So we just don't have to do that from scratch. Let's also go ahead and snap back to our game settings so exposure looks correct. Here you can even see that since we measured out the position of our physical spotlights, you can see we have one rectangle here and one rectangle here. These represent the physical lamps of our physical spotlights measured out from where they are in the studio. Could you zoom out a bit? Thank you. For instance, this square here is, as we can see in the output, the physical spotlight over on the left-hand side. It's 21 centimeters wide and 97 centimeters tall. The reason we have these in here is so we have a reference allowing us to quickly create a real lights lined up with our physical lights. In order to have well-lit AR, it's critical that you try to match your light sources with your physical light sources as close as you humanly can. We can see we've also gone ahead and done the same in the ceiling. We are using a real lights matched up with the physical light fixtures in the ceiling. And they have barn doors and measurements matching as close as humanly possible, including color temperature. So now with using simply these 4 different light sources, when we jump into live, let's quickly go ahead and just disable ray tracing while we play around with this, just so we have a smoother frame rate experience. Playing with lights is one of the biggest ways of bogging down your real-time performance. So for now, as we sort of develop, we're just going to temporarily disable it. Could you give me a nice center frame? Thank you. Just go ahead and zoom out. There we go. Now we can see that I'm seeing a bit of a overly large discrepancy between the color spaces in my output and in what I'm seeing on the screen. This is to be expected when you're working in linear space up until the next version of Pixytop, simply because the correct color conversion applied to the output is not being applied in the viewport. This is something that's going to be rectified in the next version of Pixytop. But for now, I've been clicking around a bit, so I'm just going to quickly verify that I don't have any grading enabled. I do actually have some stuff going on here, so I'm just going to ensure I've zeroed all our grading out. Going to also go ahead to composite general and just ensure that we are in the correct space. We should not be in video space, but clicking it will quickly jump us over. We should definitely be in linear space. There we go. I just need to refresh this setting, probably because I've been playing a bit too much around with my levels between these sessions. There we go. So we can here see that we already have spent some time aligning and setting up these shadows. Something you're much more likely to see the first time you have your shadows up and running is something more akin to this. Oh, sorry, there we go. So you can see that we have some shadows, but they are either overly soft or overly harsh. So what we can do is, using the 3D graphics panel, we can start offsetting the AR shadow intensity per light. So here, for instance, I can pull this down to only take down the shadows from our left spotlight. Or I can just do a global override and adjust all our shadows at the same time using a global intensity. For instance, pulling this down to, say, half of what we just had. That might not actually be too bad. I think I will leave it at that. Lastly, we can also use an ambient offset slider just to ensure we don't have shadows that become too dark. But I'm actually pretty happy with this. I'm just going to dim this to ensure we don't get this pitch black shadow on our chair. Just pull this ever so slightly. Just what I'm doing here is I'm just trying to match up the shadow of this leg with the shadow from this chair leg. Very nice. I can see here that I probably also should be adjusting this light source just to ensure that this shadow from this leg is a bit stronger, probably done by adjusting the attenuation radius. So you can just escape. We can bake down the shadow changes we just made. I'm just going to go ahead and select this light source and give it a slightly bigger attenuation radius. This is a parameter that basically says how far virtual light is allowed to affect a scene. The bigger you have it, the more of a range the light will have, but it's also worth keeping in mind that the bigger the range, the more performance impact. So I'm going to go ahead and increase it 50%. We are also going to, let's see here. I think we definitely want to keep the shadow on. I think I will just go ahead and pull up the aural intensity and just intensify my clamp instead. And there we now have virtual shadows lining up much better with our real shadows. All right. Now that we are working in a different level, we've of course lost the holdouts we just created for these handy cubes on the floor. So I'm just going to bounce back to our other level and just fetch those cubes so I don't have to measure them up again. So that's going to be this level here. I'm definitely going to save these levels. All I'm going to do in here is just grab these 3 cubes and hit Control-C to copy them, just so I can bounce back into my original level and paste them back in. Control-V, and there we go. These even retain their custom step stencil values, which means that we now have a holdout in the correct position, ready, or a shadow catcher ready to receive shadows. What this means is that now, if I were to say go in here and start pulling in some random geometries, let's see if we find something that looks interesting. We do have a lot of Paragon assets in here. We could just go ahead and pull in, say, another piece of virtual furniture. Probably a bit on the tiny side. There we go. I'm putting this here in front of the light source. This does not seem to actually be set as a shadow catcher. There we go. We can see that these boxes are now actually receiving a shadow from this virtual chair. Moving it around, we can see in the output that the shadow is being projected correctly onto these boxes. These are not ray trace shadows, but they're still pretty good. See, we can also, of course, decorate our scene. We could, for instance, pull in a logo element. At this point, once your AR scene is set up, there's no real considerations you have to worry about as you keep adding in new elements. You simply drag in your geometries and they will be AR by default. So creating an AR scene is very similar to, it's actually identical to a standard Unreal creative pipeline. Very nice. So again, like this logo on the floor, just having that correct drop shadow really helps sell the fact that it looks like it's physically present. All right. I'm just quickly going to check something before we move on. Yes. So up until this point, we've been looking at shadow catchers. But what if, say, you want to be able to cast light instead? Let's say you actually have a virtual spotlight like this lamp over here, and you want this lamp to be able to cast light onto the real floor. Well, within Pixeltope, you can do more or less everything, including this. Let me go ahead and just take this lamp. Let's bring it down to floor level, something like this. And let's just go ahead and give this a light source, which we want to be received on the floor. So what we've already done in this scene is we of course have our shadow catching plane or geometry, which is all this geometry represented in the studio. But on top of that, we have a secondary plane called a light catcher plane. This is again just a standard plane. The only thing we've done here is created a plane, right click, and we converted this to an AR light catcher. In order to not catch too much light from the skylight, we also gone ahead and given it a very dark color, just because it helps us control the amount of light being received. And now we can go ahead and add a light that will be showing up in our light catcher. So here I can go ahead and pull in, say, a real light or a rect light as they're called. I'm just going to position this within here. Let's hit G for game view so you can actually see what we're doing. Now I could have gone ahead and used a spotlight instead, as this is obviously a spotlight, but a real lights will tends to give you far better results in ray tracing. They are more expensive as well though, so it's something you might want to consider if you choose to use them. Just quickly go ahead and scale this. We're going to give this barn doors matching what this spotlight has. Something like that. And we're going to tint this to match what seems to be the color of this light bulb. So we can just go ahead and go on under details of the light. We can go up, where is it? Down, sorry, to use temperature. We're just going to adjust the color temperature until it looks reasonably in the same range. Now, if you look at the output, you might have noticed that we're not actually seeing this light represented on our floor. The reason for that is when we use light catchers, there's usually good reasons to try to be very selective about the lights that we are casting onto the real world. The reason for that is, for instance, this light source over here, which is casting light onto Dot sitting comfortably in his chair, as well as this foliage. This lamp already exists in the real world. If we are to pan the camera a little bit to the left, we can obviously see that there's already a physical light sitting there, which means that we don't need to double up that light because that light exists again in the real world. And just to convince all of you, we can even bring up the input video feed. And here we can see that light source. But the new spotlight we added has light which now only shows up in the virtual world. So what we need to be able to do is selectively filter which lights are going to be affecting the light catcher. To do that, we use a very handy Unreal feature called light channels. Lighting channels allows you to group lights to affect only certain geometries. You can set any geometry to only receive lights, say, assigned to channel 1. And then you can say that this light is going to affect every geometry, which is typically every geometry on channel 0, but also everything in channel 1, which is going to be our light catcher. Very nice. The last thing we have to go ahead and do is multiply this up. There we go, that's obviously a bit too much. The reason we have to do this is work around to ensure that we're not actually receiving the skylight in our light catcher, which means that this light probably shouldn't be affecting these AR objects, just because that's going to give us a doubling up effect. So let's just go ahead and set the channel of this to only affect channel 1 instead of both channel 0 and channel 1. Now, this also looks like it doesn't really look correct, probably because this floor is rather reflective, if I had to make a wild guess. See here. Or more likely because our light catcher doesn't play nice with the rectangular light. Learning by doing. So instead, I'm just going to quickly replace my rectangular light with a spotlight instead, which is fine because the spotlight actor is the cheapest type of light you can use in Unreal in terms of performance. It is even cheaper than point lights, and it also allows you to use all kinds of EES profiles. Most manufacturers of physical light fixtures provide EES profiles somewhere, usually on the website, allowing you to make your virtual light sources have the same sort of light texture as your physical spotlight. See here, we can easily use different EES profiles to give our light a different behavior. So now we can finally see that as we adjust the intensity of this light, and in our output, we are now casting light onto our light catcher, which is bouncing off correctly. And we're going to go ahead and use temperature, make it a bit warmer. We're going to dim this down a bit. It doesn't have to be that strong, doesn't need that much radius. It's a pretty matte floor, so it really shouldn't be too shiny. We just want kind of a tinge of an effect here. There we go. Let's also not use this wacky EES profile. There we go. So now we've successfully set up our light catcher in order to cast virtual light onto a real floor. The light catcher can also be used on these boxes. It can be used on any kind of 3D shape, the same way the shadow catcher functions. You can see we are starting to run low on time, so I think we will just move on because the process is going to be the exact same as in terms of setting up a shadow catcher. So let's get rid of these two actors here. And let me just quickly review my notes. Okay. Now, we've looked at all of these different actors and what you can do with them, and I think it's time for us to move on a bit to compositing and how you can improve your compositing workflow. So let's again go ahead and pull in a virtual character, just so we have something pleasant to look at as we work our way through how to improve our overall compositing. I think here we are going to go ahead and pull in Sparrow again. Just going to go ahead and give her a static pose. And we are going to make this pose an idle loop. There we go. Could I possibly pass you to set up the light source again? Yes. We're going to be playing with a few different interesting features like light wrap and similar. So we're just going to quickly connect a new light fixture here in the background. Very nice. Now, since we now have a new light source in our scene, let's also go ahead and create a new virtual light to match that new light source. So that's going to be a new area light. Let's see here, light sources, area light. Could I also pester you to measure up the size of the light? We're going to go ahead and add a new rectangular light. Actually, we're first going to add a cube just so I know where the position of the light source is. Just waiting to have a report back here. What's the size? So this is a 19 by 23 centimeters spotlight, at least the light surface. So we're just going to take a cube, 0.19. We have to turn off universal scaling, 0.9 by 0.23 to make it 19 by 23 centimeters. And we are just going to use this geometry to quickly position the light in the 3D space. I know for a fact it's going to be pretty close to the wall, probably around this distance. To do this correctly, you definitely should consider measuring things out with a ruler. But for now, I'm going to be content just eyeballing it. So what I'm doing here is I'm simply looking at my return feed to ensure that this cube matches the position of this new physical light. The gizmos in Unreal are pretty intuitive to use and user-friendly. You can change between them using these three buttons here at the top, or you can simply use Q, W, and E to bounce between them. Sorry about that, W, E, and R. R for scale, E for rotation, and W for location. You can also, of course, click it to manipulate your objects. I am personally a huge fan of not using the gizmo just so I can look at other things as I'm working, for instance, the output feed. Luckily, there's a default hotkey to do that within Unreal. Simply hold Control, and then you can use your left mouse button to move things or scale things or rotate things along the X-axis or the red axis. Right mouse button to move, scale, rotate along the green axis, which is Y, or use both mouse buttons at the same time to do this along Z. If you ever get used to this, you will never use the gizmo again. It can be a pretty huge time saver. There we go. Now that we have this positioned, we are going to go ahead and pull in an area light. Yes, rectangular light. Ensure that it's pointing the right way, which it currently is not. Ensure that it has the same dimensions, 19 centimeters by 23 centimeters. We're just going to slide this on in here. Just like that. And we can see that it has to be rotated as well. Very nice. And now we don't really need this reference cube anymore, so I'm just going to go ahead and delete it. Actually, yes, we do need it because, of course, since there's AR behind this lamp, we can see we have a logo fixed up on the wall. We might actually want to take this new geometry and convert this to a holdout. So you can see now we are actually able to occlude the AR sitting nicely behind our new light fixture. Could I possibly pass you to zoom in so I can see what I'm doing? We're going to see a bit of stuttering. That's simply performance issues caused by me being an editor. Performance is notably much better when we are A, running in live mode, as well as B, not running with VSUVIG active. VSUVIG is great because it allows me, as well we can see, have a live output feed from our trike camera at any given time. But it also means that we are rendering the scene twice every single frame. And if you put the ray tracing on top of that, that means you are putting some serious stress on your hardware. But it's still perfectly doable, perfectly fine to do this. But here, as you can see, doing this adds, basically using VSWIG is eating up about 60–70% of our overall performance. If we were to go to our optimization tab and look at the reason, in case you're wondering, the reason the VSWIG is using more performance than the viewport is simply because the viewport is scaled smaller than 1080p, meaning that the output is a higher resolution. So if I bring up the unit graph where we can see the performance graph in green and turn off VSWIG, we can see the performance improve immediately. We don't really see a big step up simply because we are going to be genlocked at 20 milliseconds. But you can definitely see that before we turn it off, we are not hitting our target frame rate, which is 20 milliseconds at 50p. Turning it off, we can also bring up this debug again. And we can see that now rendering our entire scene is taking 7.6 milliseconds, as opposed to before, where we were using a grand total of same 7.5, 7.6 milliseconds for a scene, plus 11.2 milliseconds for our output. I'm just going to leave VSWIG enabled, simply because it's going to allow all of you to watch the live output feed as I keep working. There we go. Now that I have this converted to holdout, I can also just look at the actual projected video onto this object to see if I'm somewhere in the ballpark. It's worth mentioning that the actual light fixture is going to be slightly bigger because there's of course a plastic frame as well. So let's just go ahead and scale this up a tiny smidge. And looking at my output, that doesn't seem half bad. It's a tad too wide. So I'm just going to scale it down along the Y from 25 centimeters to say 24 centimeters. If we zoom back out, there we go. We are now correctly occluding our logo behind this new actor in our scene. We're also seeing a crosshair. I guess we've been seeing that all along, I just didn't notice. The crosshair is a utility used in our calibration tracking setup for CCD. I'm just gonna go ahead and turn it off because we don't really want to be looking at that in our scene. There we go. Now I'm going to quickly dial in the parameters of this light so we get the nice rim light on our character from behind. Now the actual light in the back there isn't that strong, but we're just going to pretend it's a 50,000 lumen floodlight just so we get a more interesting, aggressive rim light, just because it makes things pop a bit more and it can look nice. Now we do, so we can see now that we are getting some pretty nice pings, some pretty interesting rim light. The shadow, on the other hand, seems to be a bit too strong. So I'm just going to go ahead and we could select the light source, search for AR and just take down the AR shadow intensity. But we can also do that later on in live mode through the director interface. Let's actually move this down to line up with the holdout. There we go. Let's also name it so we know what this light is. This rectangular light is going to be our spotlight back. There we go. The last thing I'm going to do is I'm going to find my art ray tracing toggle blueprint. And to ensure we have proper performance when we jump into standalone live mode, since we have added a lot of more light sources, so this is starting to become a very heavy scene, just due to the amount of lights we have if we intend to use ray tracing. I'm going to go ahead and bypass reflections, so we only ray trace shadows, which is, since there's nothing too reflective in the scene, shadows are far more important. And changing this allows us to still use ray tracing, but still also hit our target frame rate. I think there's good odds we would be hitting the target frame rate anyways in live mode, but for now, let's just disable it. I'm pretty happy with how this looks. So let's save this, bake any adjustment we might have made in the editor, save the scene, and jump out into live mode to start fine-tuning our composite. So save everything here, go into our director interface, just double check that we have ray tracing on, which we do, and we're going to go ahead and launch our backdrop scene in live mode. This means that we are now, instead of rendering both the viewport and the final SDI composite output, we are only rendering the SDI composite output and drawing it both on my computer screen as well as the output feed, which means that we'll be getting a much smoother frame rate. There we go. Now I can see there's something going on with my holdout cubes here, probably because they are set to be shadow catchers. They're probably catching too much shadow from one of our light sources. We can also, by hitting Control-Shift, we can access GPU profile, which is going to tell us that we are still ray tracing reflections. Now, we probably don't want to be doing that, so we're just going to quickly trigger the blueprint we just adjusted in the production tab to get rid of our ray tracing settings. Why do I have these open? I don't need these control panels today because we are focused on AR. I probably shouldn't delete that. I'm gonna have to remind myself to roll back instead of push my changes to source control after this session. Let's go ahead and close this mascot panel as well. And just quickly toggle ray tracing on and off. There we go. Which is now giving us better performance, but still ray traced shadows. Now I can see there's something going on with my cubes on the ground there. So I'm going to quickly try to remedy that by selecting the cubes on the floor. So simply going to the adjust object panel will, as always, allow me to adjust anything on the fly. I'm pretty sure I didn't rename them, so I should be able to just search for cube. And it's going to be one of these cube actors. It's going to be hard to tell which of these I'm looking for, so I'm afraid we're just going to have to start adjusting them. I'm going to toggle visibility. Seems like I caught 2 of them. And all I have to do is, instead of these cubes being shadow catchers, I need to ensure that they are reflection captures. No, sorry, they're holdout objects instead. Now, sadly, since I don't know which specific cubes I need, I'll just have to dig around and do these one by one. Let's actually keep the director open so and just look at the output on the webcam feed. So it is the holdout. That's 1 out of 3. And this is also why it's very important to name your actors so you don't get stuck in this situation. This ties into having good naming conventions and good practices building your sets, which I obviously have not been showcasing during this session up to this point. 2 out of 3. I know for a fact it's not going to be this one, so maybe it's going to be this bottom. It's not going to be this bottom one because it's not set to AR Shadow Catcher. Let's just do these 3 at the set. Let's do this the way we've been doing it, one at a time. There we go. Keep fat fingering it. Yeah, so this is actually the back fixture, as we can see, which definitely should be a shadow catcher. Maybe it's this one. It's not this one either. On the con side, this is not that interesting to look at. On the pro side, we are certain to get it soon because there's not that many more to choose from. We are definitely going to see it being the absolutely last one I choose, I suspect. Interesting. Let's go ahead and do these last few ones. There we go. We could also, of course, try to identify the light giving us issues. I'm going to assume it's going to be the new spotlight we just added. If we just search for back, I believe I call it spotlight back. If you just set the visibility of it to be invisible. That's not the one giving us issues. So what I'm doing now is I'm quickly trying to identify what I've said wrong to obviously kill my back shadow caster here. Let's see here. Let's first just reinitialize our ray tracing settings. I believe this might be caused by a composite effect. It's not a shadow. It's not a light wrap. At this point, let us just disable ray tracing and try to resolve this in a second. For now, let's do a deep dive into our compositing. So you can see here that this is already starting to look rather nice, but our graphics might look a bit flat. They're kind of missing some of the contrast that we are seeing in the video. We could, of course, now jump into our color grading suite and just do a quick color grade pass. For instance, by enabling this, let's zero out all these settings. Let's make this a bit bigger so we can see what we're doing. And we can start pulling the sliders to just start to a quick grade pass on the graphics. We can see that our red might be a bit aggressive. We can easily selectively tone down saturation on the reds. And I could also bring up the gamma a little bit, which I actually, in hindsight, probably don't want to do. Instead, I might opt to just push the contrast just to get some deeper shadows, trying to avoid clipping to black. My supervisor always tends to get a bit unhappy when he sees black pixels in my composites. There we go, perfect. Now, could I pass you, Magnus, to zoom in at the head chest area of Sparrow? So now we obviously have this brand new, very hot light source directly behind our character. It's actually probably a bit too hot. I can see that rim light is a bit too aggressive. So we can quickly adjust that by going into the spotlight back and adjust the light intensity. Now, sadly, I did forget to expose that property because we don't expose all properties by default. So I'm just going to have to quickly jump into the editor by jumping into the scene and expose the light intensity property so we can access it during runtime. Thank you. Okay. When it comes to properties, we are actually able to control any property on any actor using Director on the fly. We've mainly been using mobility settings. We've been toggling visibility on and off, as well as offsetting transforms on our different actors. But there's also far more interesting things we can choose to do if we'd like. So we're going to select the spotlight at the back here. And we are going to just go ahead and take down this corner angle a little bit. There we go. We are going to go ahead and expose the light intensity parameter just by clicking this little checkbox next to the parameter. You might notice there's a little star next to every single parameter on every actor within Pixeltope. This is what you click to expose those parameters to Director. So I'm going to expose intensity. There's good odds I might want to be able to change color temperature on the fly as well. So let's go ahead and expose this parameter as well. Visibility is exposed by default. I don't think there's anything else I need to be able to change. We could, just for amusement's sake, also expose light color, just so we can see that working. We're also going to bake all the changes we just made in editor. See here if we can figure out, oh, I think I know what's going on here. Yes. So the reason we're having this insane artifacts on the backdrop is because we converted it to one of these actor types, which also changes the assigned material. Resetting this is going to take the black away because it had a black backdrop material applied. There we go, that was the issue, and now we are back to where we want to be. That means I could probably do the same thing on these things as well, convert them back to shadow and reflection captures. They should work as intended. Very nice. So again, we're going to save this and try this again in live mode. So we're going to launch this in live on this computer. Come to think of it, there's not really any point in me constantly closing and reopening this in separate live mode. If I were to play this in live within editor, we would have more or less the same effect. So I'm going to stop doing that. Simply because if you play in live, that means you're no longer using VisuWig per se. You're now rendering the same output to both your output SDI feed as well as your screen. Okay. So you can see that I accidentally changed the stencil of the cube in the background. We'll fix that in a second. But for now, let's start dialing in the light being cast by a spotlight, which I actually can't do because I can't see the light source. So we have to do this in the editor. Okay. Sorry about this constantly bouncing back and forth. It's simply my fingers running ahead of my brain. There we go. So again, the same issue on this thing. It has the AR black backdrop material, which we don't want to use because that's used for very specific use cases. And now we are back to where we want to be. So instead of exiting and launching a separate live mode, I'm just going to play live in editor and hit F11 to full screen my view. Now I can dive into the production tab. We can finally go about setting up our composite. First off, our light source, the spotlight back. We can now see that we have a bunch of new interesting properties to play around with. I could, for instance, select the light color, zoom out a bit so we can see all of this in one view. There we go. And I could change the color on the fly to anything we like. So if the physical spotlight was green, I could easily replicate that in here. Generally though, it's usually a better idea to just offset the color temperature instead. So we'll go ahead and set this to maybe, oh, I was missing a 0. That's a very hot lamp. There we go. And we can also make it a bit less aggressive. You can see it's a bit much in the hair. It's also a bit too hot. Go ahead and go to intensity and take it down from maybe 4 to 2. There we go. Now, we've gone ahead and set up a virtual spotlight in the back so we have the same light source, which helps a lot. But we can still see there's a bit of a hard transition at the edges of our characters and the back wall. We don't really have bounce light because we are not currently using the ray traced reflection model with the virtual studio double that we've talked about earlier, which you might not have access to if you're using a very heavy scene with maybe tons of actors running around, or if you don't have access to an RTX card from NVIDIA, if you're using something like a 1080 Ti instead of a 2080 RTX Super. Those are graphics cards, in case you were wondering. So instead, we're going to go to Composite. And here we can do a lot of interesting things. So far, we've been looking at shadows, both global settings as well as per light offsets. We can also do colored shadows if we wish to replicate and have correct shadows, colored shadows onto a ground, mainly relevant if you have colored lights. But we're just going to go ahead and look at the light wrap on the left-hand side. Light wrap is something we've built into our composite pipeline, both for our 3D graphics as well as video. And it is basically the action of blurring either the video feed or the graphics feed and using that blurred image to bleed in across the edges of your video or your graphics. Here we're doing AR, so we're going to blur the video plate and bleed that blurred image in across the edges of our talent. In case that's a bit abstract, let's just take a look at it instead of just talking about it. So I'm going to make it a pretty strong effect so you can easily see what's going on. And we're just going to bleed in very aggressively. As you can see, we are now taking the video feed. If you look at the light source, for instance, near the pit of her shoulder, we can see that data being bled in very aggressively. This is, of course, using a gain value over 2, which is never recommended because it basically is going to push your values up into non-PBR range. 1 is still pretty aggressive, but at least it's not going to over brighten this bleed effect. I personally prefer values around 0.6 to 0.7, just because it gives us a very nice subtle effect. But just for amusement's sake, let's keep this at 1 for now. So alpha blur will blur in the alpha, allowing us to bleed in along the edges, whereas background blur will blur the actual background. This has some performance overhead to it, so just be a bit mindful of that. This is also a pixels per pixel blur, as basically a pixel space effect, meaning that if you zoom out, it's going to look like the light wrap effect is growing, simply because the graphics is going to be fewer pixels in size. So 5 pixel bleed in is going to mean a lot more. That's why we also have this fade distance, allowing us to fade this effect out as we pull away from our talent and our graphics. So I'm pretty happy with this. We can turn it on and off. You can see it basically just gives us a bit of a slight rim light effect, like a Fresnel thing bleeding across the edges. The background blur is still a bit aggressive, so I'll pull this down to maybe 2. And that is not too shabby. Oh, sorry, not the background blur, it's the alpha blur. Just to keep it a bit more tied up at the fringes, as we are seeing here. You can also see at the foliage at the sides, especially on the right-hand side, it just helps bring up some of those very dark edges. I personally feel it's bringing them up a bit too much, so we're not going to set them to 7, we're going to set it to 0.7. And if my colleague Magnus were to go in and just try to wiggle the light, because we want to go back to the original position, so don't move it, just bend it to the sides. So you can see as Magnus moves in, he is actually going to be bleeding instead. And as we move the light source, keep going, push it further. As we push it to the other side, we can see the Fresnel effect happening on the other side instead. Very nice. Thank you. You can just leave it back where it was. That's pretty close. Thank you. Nice. The next thing we would like to do is bloom our graphics a bit. We can see that there's no bloom currently happening. The arrow looks pretty flat and lifeless, despite being a very highly emissive surface. So we're just going to go ahead to our graphics adjustment and just re-enable bloom, because I overrode this earlier within the level. See here, I might also have some rather bogus values. Oh, that's a bit much. There we go. So by pulling down the threshold, I'm now able to start applying bloom from this glowing arrow onto the graphics themselves. I can also choose if I wish this bloom to bleed from my graphics onto the video, which we are currently seeing. That's a bit much. The easiest way to fix this is actually probably going to be to adjust the emissive values of the arrow, because these values are rather extreme. So let's just bring this back to a reasonable range. Let's jump into our scene just so we can quickly offset this glowing material instead. If, of course, I can find it. Let's see here. It's probably going to be this arrow material. I'm just going to quickly open it. And we are going to see if we can find an emissive value somewhere in here. Are we using a material instance of this? No. Okay. So what I'm doing now is this is not the material created. I'm just quickly backtracking, following the path of the emissive color to find out where the emissive color comes from, so I can just kind of crank it up a bit. This looks promising. Let's adjust this edge brightness value. Perhaps a little bit. We could, of course, also just go ahead and multiply the overall emissiveness of the arrow. We can just actually be a bit lazy and go ahead and add an emissive value as well. This is not a very clean or correct way of doing it. I apologize to anyone from Epic who might be watching, but it's just for the sake of efficiency, just so we can move on. Let's just give this a nice, bright, emissive glow. There we go. So this is actually an emissive color. It's actually a very glowy color because we pushed the value over 1, I mean. And as you can see, that brings this up into self-illuminating range. We are going to go ahead and save this, which is going to take a bit of time as this is a fairly complex shader. And we should immediately be seeing the arrow become much brighter, which is going to make it easier for us to separate it out for a separate, to have a more sort of isolated bloom effect. There we go. So that's obviously very high, but that's perfectly fine. Because now we can go ahead and selectively go in here and take down the intensity of the bloom as such. It's a bit much, but this is just a showcase that we can actually bloom from virtual objects and that bloom carry over across the video feed. We can also choose to turn this off if for some reason the director is telling us not to see. It seems to be spamming a bit, but we can also turn this effect off if for some reason we do not wish to affect the video plate more than we have to and not apply blooms that bleed across video pixels. For now, we're pretty happy with how this looks, so we're going to leave this as is. It's a pretty gnarly yellow. You know what? I'm actually going to spend just a half minute just so we don't have to look at this for a remaining 20 minutes of this session. Let's just go ahead and quickly desaturate this a bit so it's a bit easier on the eyes. Let's also convert this to a parameter so we can change it on the fly without having to constantly recompile this shader. Because it's fully saturated, it's burning out towards yellow, but I would much rather have it burning out towards white, just because that tends to look less gamey. It's going to be easier on the eyes. Now we more or less covered all the basic and some of the not so basic composite utilities within Pixeldope AR. So now the last thing, just to mix this up a bit and do something completely different, we're going to set up some controllers for this AR character so we can operate our AR graphics from our Pixeldope control panel interface. There we go. Now that this is a parameter, I can actually change this on the fly and see this being output on the go. Let's give it a little bit of heat. Not too much. There we go. I'm happy with this. We're just going to go ahead and close this. Yes, I do want to save this. Please do not recompile. And we are going to move on because I am really starting to get a bit too carried away with the creative process here. Okay, so we're going to clamp our bloom at, let's say, 2, 3, and then let's see, something like that. And then we are going to move on to our control panel logic. Okay. So in order to operate graphics, operate basically any kind of graphic within Unreal and Pixeltop, you are going to need to learn how to use blueprints. For those of you who don't know what a blueprint is, it's a blueprint can mean many things, but what we are most commonly talking about when we talk about blueprints is the way you visually program something within Unreal to move actors, spawn actors, trigger particle effects, drive infographics using 3D text geometry or any kind of data representation. Blueprints is how we make our graphics move. An example of a blueprint, of which we have quite a few, is, for instance, our mascot sitting over here. We haven't been seeing him doing a whole lot, but he has a pretty extensive blueprint. Let's see. He doesn't have a blueprint at all. But his big brother, who is able to walk and talk, let's see if we can find him. Let's see here. Now, where has he gone? He's definitely going to reside underneath the Pixeltop mascot subscene. It's probably going to be, there we go. He just doesn't have a thumbnail. That's why I'm seeing him. So a blueprint is basically like a collection of assets plus visual programming nodes. In this blueprint for our handy mascot Dot, we of course have his skeletal mesh. A skeletal mesh is like, it's a rigged character. It basically is a 3D mesh with a accompanying skeleton, which you can see here, and usually tied to animations, which means that we are able to move these bones using animations, which in turn drive this geometry, allowing for our characters to walk and talk and do interesting things. Like here we can see our character Dot has quite a few animations off the bat. Some of these being pre-canned motion capture sessions that we've been cleaning up, and some of these being manually animated by my dear colleague David Rodriguez. Other actors that are typically see in blueprints are lights, geometries, basically everything you want to drive using your programming logic. So in this particular blueprint, we have a bunch of audio source, audio emitters, we have a bunch of separate geometries for detachable body parts, and then we have the blueprint which drives all of it. Now, I understand that this can be pretty intimidating to look at, especially if you happen to be an artist like me or not a programmer by heart. But blueprints are incredibly easy to get into, and they're easy to start using within a day or two of warming up. The reason there's a lot of logic here is just because this character can do a lot of different things. But if, for instance, you remember the media logic we looked at yesterday, the logic that actually controls the media we play back on the chest is simply these 6 nodes right here. So this blueprint is just a collection of smaller tasks that deals with different aspects of how this character behaves. So this could also be a separate example of a blueprint, which is just tucked in with a lot of other little clusters. We have an event triggering a particular video file. We have another event triggering another video file. These change between 2 different video files, and then both of them execute an open source operation, which opens the video file and starts playing it back on the chest of our character. So these are blueprints. And again, if you wish to do anything overly exciting with Virtual Studios, you definitely should dive into blueprints starting today. There's also a different kind of blueprint called an animation blueprint, which is more specific for virtual characters, or characters in general, as well as basically anything that needs to play back animations within Unreal and Pixeltop. Animation blueprints are still a blueprint. They still have event graphs where you see the same triggers that set parameters, they do things, they execute things in different orders. But animation blueprints also has some unique logic pertaining to animations. They have something called state machines, among other things. So here we have a large mess of logic, which we are not going to care about, just because it is going to be a bit too much. All we care about is the state machine, which you can see here, which drives the animation of this character. A state machine is like a network of different animations or states that a character can have. If you think of a typical game character, when the game character is just standing around in your scene, you can consider that being an idle state. Typical animation where you're just kind of hanging loose, waving his arms, looking around, not doing anything in particular. From that idle state, we need to think of all the different other states we could enter from that particular state. The character could start walking, could start running, could start jumping, could start crouching, could start doing a barrel roll or a taunt animation. All of these would be new states that we are able to access from this idle pose. Let's say that this character is Superman, and we have an idle state, but we also have a flying state, where instead of standing around, we are now animating a character to be holding the classic Superman pose, soaring around in the sky. We shouldn't go directly from this idle state to this Superman pose because we have to blend between them, ideally using a takeoff pose. So if you're going to say that our character is starting at an sort of an idle pose, which probably is going to be, let's say here, we instead of enter into this walking animation, we're just going to enter into an idle pose. From this idle pose, we might be able to click a button that says take off or jump or fly. Then from this idle pose, we can go into a new state called take off. And at the end of takeoff, when we are done doing our launch into the sky, we are now ready to go into our flying pose, which is just a looping Superman hero pose, flying. You see these little handy arrows? These are rules saying when we are allowed to go from one state to the next. We can see some places we are only allowed to go one way. For instance, the mascot is only allowed to exit from this idle pose, but we are not allowed to go the other way around. We have to go via this walk-in pose if we want to go back in. The same thing applies here. In order to go from idle to takeoff, we could make a rule saying that we can have a new Boolean variable let's see, allow to fly. This is a Boolean, which is a value of 0 or 1, 1 typically being true, 0 being false. And we can say that if we set this variable to be true, if this is 1, then we are allowed to enter the transition, which is going to take us from idle to takeoff. And then we could say that when the takeoff animation is almost done playing, then we could have a separate rule here. You could check, we can just get the current, let's see. Yeah, get relevant enemy time remaining. This is going to tell us how much time is left of the takeoff animation. And we can say that if there's, let's say, if the remaining time is equal to or less than, let's say, 0.2 seconds, which is a good blending time for animations, we are going to blend into our flying animation. So when we are almost done with the takeoff, when we almost finished going into our superhero pose, we are then going to transition into the next state, which is going to be flying, which is then going to loop forever. And since we haven't made rules going back to takeoff and idle, our character will never be able to land and walk among us regular mortals again. He'll be stuck looping, flying forever, unless we start making rules allowing us to blend back as well. This has all been a bit abstract, so let's look at what this, well, let's take a look at what this means in action. So this right here is a skeletal mesh, which is just looping an idle animation forever. there's no animation blueprint here, so she's just playing this animation over and over and over until the end of time. But instead of doing that, we could go ahead and create a blueprint using an animation blueprint to start making some buttons and triggers and checkboxes, allowing us to control our character. Let's see, I don't really want you here. Get out of the way. Thank you. We already, well, David has already gone ahead and made an animation blueprint for this particular use case called ABP Sparrow Pixapalooza. Just because we don't want to do that from scratch here, we can see that David has already put together a state machine where the moment we start simulating our game, basically the moment we go live or hit play, we're going to directly dive into our start pose, which is going to be sort of a hidden pose or off-screen waiting pose until we enter our character. This is very typical for AR characters. If you don't want them to be on stage from the very start, you might want to have some kind of intro animation or particle effect, or have the character solidify or drop from the sky or burst to a wall before you go into your looping idle pose, which is what we are seeing here. The way this is done is that we start in our start animation pose, and this initial animation has a play rate set at 0. As you can see, play rate basis set at 0, which is actually it's set somewhere else. It's not set here. But basically, this variable here, start enter animation, it should actually be named start animation play rate, has a default value of 0. And this is plugged in somewhere to control the play rate of this very first animation. The rule allowing us to go from this start pose into our idle loop is, if we double click here, we are checked. Oh, Jesus Christ. Should always try to line this up so it's actually readable by the people that come in after you. There we go. When our start animation has less than 0.2 seconds remaining, we are then allowed to enter this transition, blending from this pose to our idle pose. Given that this first pose animation has a play rate of 0, meaning that it's paused at the first frame, we will never be able to go into idle unless we set the play rate to be 1, which then will take us from this pose to this pose. When we are in idle, we can see that we have 3 different emotes we are able to go to. We can do this bow balance animation. We can make Sparrow do a handstand. And we also have this sort of bow taunt pose, which we are allowed to trigger from idle. As these animations are done playing, we can see that we check the remaining time of these respective animations, and when they're almost finished playing, we'll automatically be blending back to idle. So all of the rules out of these are simply going to be Boolean check, do bow pose, do bow balance, and do handstand. Simple Boolean switches where if we flip them, we're going to blend into these different emotes. And then at the end, we have sort of a exit animation, which we can trigger, and it's going to play and then blend back to our completely exited state. So let's start building a blueprint and see how we go about utilizing this animation blueprint and connecting it to a control panel. So we're just going to go ahead and create a new blueprint from scratch. It's going to be an empty blueprint. We're going to call it BP Sparrow Session 2. That's a very bad name, but it is what it is. There we go. Now there's not a whole lot going on in here right now because we haven't added anything yet. So we're just going to go ahead and add, not an animation blueprint, we're actually going to go ahead and add a skeletal mesh. So the cool thing is all of these skeletal meshes are different skins of the same character, but they're all using the same skeleton and the same animations, meaning that we can choose whichever of these we would like to use logic. I think we can just go ahead and scroll, which I think look quite nice. Accidentally clicked the wrong one, so we have to wait for this before we move on. Skeletal meshes can be rather large. It's fine to be using these in your scenes, but just keep in mind they can be a the first time you open them, they might be a bit slow to load. This one looks pretty nice. It has an interesting outfit. So let's use this one for this particular blueprint. We can easily replace these or toggle between them at a later point in time. So now we have our skeletal mesh, and then we are not going to be using a animation as we discussed, we are going to be using an animation blueprint. So for the details of this skeletal mesh, we're going to go to animation class. We're just going to search for ABP, and we're going to be using the Sparrow Pixapalooza animation blueprint. The moment you set it, we can see we are now snapping to this sort of default pose, which is before the idle pose, which is just going to be a static, non-looping animation until we actually play it. Now, to save us from a little bit of fumbling, I'm just going to open up my cheat sheet over here on the side. It's going to be this one. Just pretend you didn't see that. Over here, thank you. And we are going to start by making a bit of logic. So we can do this step by step. The first thing we'd like to do is make a single button that we can click to bring our character into our virtual set. We're not going to build all the logic to hide the character. We're not going to do any material assimilations or move the character with a walk cycle. We're just going to start from a static pose and go into our idle pose. To do this, we need to interact with our animation blueprint from this sort of parent blueprint for the character. In order to do that, we need a variable we can reference. So we hit this plus variable tab, and this variable is going to be of an animation blueprint type and ABP Sparrow Pixapalooza. The reason we have to use a variable is because there's good odds we might be using the same character multiple times in the same production. Let's say we're using 4 copies of this blueprint just with different skins, and all of those characters would then be using different animations. That means that we need an instance of the animation blueprint for each individual character, which is why we need to make it a variable. I'm going to name this ABP character blueprint. The first thing we're going to do on begin play is simply populate this variable. We're just going to assign the blueprint on the particular skeletal mesh in that particular instance of the blueprint. So we're going to drag this in. We are going to set the value of this variable. That is going to be the animation blueprint of this skeletal mesh. So we're just going to drag in a reference to the skeletal mesh. We are going to find out what the animation instance is on this skeletal mesh. This could be a looping animation, but we know for a fact it's going to be an animation blueprint. This always throws me a bit off guard because it's not get animation instance, it's get anim instance. Then we are going to cast this. We know this is an animation blueprint. So we're going to tell the blueprint that, hey, this is animation blueprint, ABP Sparrow Pixapalooza. This is known as a casting operation. And we're going to take this final output and input that into this variable. Now we are creating a reference on begin play, allowing us to start interacting with our ABP. So let's take a look at this ABP. Let's simply find it in a content browser and open it up. So we can see under event graph, we have a bunch of different triggers already set up. Trigger bow, trigger handstand, and trigger bow balance. These are the different taunts. We also have trigger exit and trigger, where is it? No, we don't have trigger entry because that's not a trigger, that's an animation play rate change. So the first thing we're going to need to do to enter our character is simply change the variable of start enter animation from 0 to 1, or at least something which is non-zero. We can go ahead and do that right now. We could also say that on begin play, we set this character to be hidden in game, meaning that the character is invisible until we are ready to enter the character. We can set the character to be hidden in game. Compile it, save it. Now, if we pull this blueprint into our scene, which I actually forgot to do. Could we get a nice full frame of our floor here? I hit Control B just to find the blueprint in my content browser, so I can quickly drag it in. Let's go ahead and put our character over here. So here we can obviously see our character both in the output and in our editor. But the moment I hit play, if you look closely here in the blueprint logic, we are going to set hidden in game to be true, which means that when I hit play, the character becomes invisible. So again, you saw this fire off, which sets the character to be hidden in game. Okay. So the next thing we want to do is, now that we've prepared a character, we would simply want to trigger an enter animation, which we're going to do by making a new custom event. Let's call this, we always prefix our events, the events that we want to access from our control panel with PX, just so they're easily identifiable. And this is going to be PX, or for Pixeltop, enter character. Goes to just, that's unnecessarily long. Let's just say, call it PX enter. Short and sweet. I'm not going to make the control panel buttons right away, just because I want to ensure my logic is working first. So I'm going to go ahead and click the checkbox in the top right corner called Call in Editor. This is going to put a little gear on this custom event or this trigger. And we can see now that clicking the blueprint, I now have a new little widget in the details panel, allowing me to manually trigger this event without having to make a control panel. Then we're going to pull in a reference to the animation blueprint, because when we fire this off, we are of course going to trigger, no, we're not going to trigger enter. We are going to set a variable. I don't remember the name of it, so let me see if we can find it in this list. We are going to set start enter animation. It should be named set start enter animation play rate to 1. And that's really all the logic we need. That's not true, because we've actually hidden our character. So let's make sure we also unhide our character the moment we start playing this first animation. Drag in a reference to the skeletal mesh, and we're just going to set hidden in game to not true. And then I'm going to select all these nodes. I hit C for comment, and we're just going to describe what these nodes do. This is the same as adding a bit of commentation in your code if you're a programmer. It's always good to document as you go along to ensure that the people that work with your blueprint after you understands what your logic is supposed to do. Autosave always fires when I'm typing text, ensuring that my text typing is interrupted. It is the bane of my existence, but such is life of an Unreal artist. What was I doing? Oh yes. It's the little things, but it's not too bad. Now we can test this logic by hitting play. Let's also bake all the changes I made in Director just so we can save them in the level. There we go. There's no character. And let's just be able to click the blueprint. Let's actually look at the blueprint logic here. The moment I click this button, PX Enter, is going to fire off PX Enter. We are going to see this white line, this execution order fire off. And hopefully there's a character jumping in as well. Very nice. She looks a bit dark from the right, so I'm actually going to quickly go ahead and select my right light. Why are all my light sources named left light? That's a bit sloppy, isn't it? I think it is. I'm just going to select this right light and actually name it. There we go. And let's make sure we have a little bit more light coming in from that side. There we go. And let's trigger this one more time, just to make sure the first trigger wasn't a fluke. There we go. So we trigger the enter, as the enter animation is done, we blend to the idle, which is this sort of bow pose that will just be looping forever and ever and ever. Cool. Now that we are in our idle pose, if you remember from our blueprint, our animation blueprint, we can actually watch this animation blueprint as we fire off the logic. Let's just set debug to be using our character. So as we hit play, as we fire off our logic, we can actually see, let me just reset this, there we go. We can see we are currently in this waiting pose. And when I select the blueprint we just made and enter, we finish this transition. And then when it's done, we just jump to idle. From here, we have a few options. Among other things, we can jump to all these different taunt animations. Let's quickly go ahead and make logic for that as well now. We have 3 different taunts. I'm quickly just going to make 3 custom events using copy paste. These are going to be PX bow balance. They're going to be PX bow. I'm hitting F2 in case you're wondering how I'm renaming this on the fly. And it's going to be PX handstand. The logic of these is going to be even more simple than this. We're just going to get the reference to the character blueprint. And we are going to, let's space these out just to organize things a bit. Very nice. There we go. We're going to pull out and we are going to set do bow. This is actually bow balance. Like so. The next one is going to be set bow. Like so. And the next one is going to be set handstand. There we go. Right now, none of these are going to work because we can see that all of these sets the Boolean to false. So let's check these checkboxes to set these Booleans to true, ensuring we are able to go in and do all these actions. Let's then go ahead and select all of these and enable colon editor, just so we have some more debug buttons to press instead of having to set up the control panel right away. We're going to comment these, and these are going to be triggers different taunts. We can also go ahead and just introduce our last piece of logic as well, which is going to be custom event PX exit, which, as the name probably alludes to, is going to simply exit our character by triggering exit. I just now realized that what I've done here is actually very silly. I've doubled up the logic of all these trigger boxes. So instead of using the trigger function, I'm just directly setting these variables. This is fine, but it's also a bit messy. So instead of setting these variables, let's leave unto Caesar what is Caesar's, and let's use the trigger logic that the animation artist already set up for us. The reason it's a better idea to use these events is because there's good odds that as development progresses, the animation artist might want to change this logic, meaning that if we are replicating this logic, this might not work if the animation blueprint is to change, but these triggers we can assume is always supposed to trigger and do the same things. I can see I have some unread messages over to the side, so I'm certain I have at least one of my colleagues that called me about to make a pretty huge mistake right off the bat. It's good that we have someone that knows what they're doing watching this stream. There we go. And just like that, we now have all our logic set up. We have all of them with colon editor functionality. And we can now go ahead and verify that our logic is behaving as intended. So we play an editor. we can select our sparrow, and we can go ahead and trigger PX Enter. There's our character. Then we can go ahead and let's see, we can do the bow pose. You can see now get a handy little flaunt there. We can go ahead and do a handstand. Very cool. Nice example of cloth physics within Unreal as well. Whenever we are done, we can do a PX exit, where we first play our sort of exit animation, and then our character is gone. Now, I've actually haven't set logic up to hide the character at exit, which means that she'll be stuck in her idle pose as is. But I see we're running dangerously short on time, so I think it's time for us to move on. We don't need this to be perfect. I mean, this is something you can build on forever if you so choose. And the really cool thing is, now that this logic is set up, is nothing stopping us from, let's say we can go into our blueprint again. This one here, I believe. And I could, for instance, grab my skeletal mesh and replace it with a different variant of the same character. But all the logic is still going to work as it was before, because the skeleton is the same and the animations are going to be the same. So let's save this, and let's jump into this in standalone live mode. I could of course do this from play in the editor, but let's take a look at how this will work for more of a technical operator during rehearsal or live broadcast. I'm going to go ahead and save everything. We're going to launch this in live mode. The reason we are doing this is because someone that's working as an operator or mainly working in the director should never really have to go into the editor to change things or make blueprints or do any kind of crazy Unreal specific action. We need to be able to interact with the graphics even if we don't really have much Unreal knowledge. So for the sake of amusement, let's pretend now that I'm an operator. I don't really know Unreal. All I wish to be able to do is, let's see, wait, see here for a second. There we go. All I need to be able to do is grab a blueprint, which an artist has told me is called Sparrow, and I need to be able to build a control panel for this character. So we are going to do just that. We are going to create a new control panel from the director. There we go. Give this a second to generate this new control panel. No. There we go. And we now have a clean blank slate to work with. We're going to add some widgets. You can see here we have logic to make numeric input fields, text input fields, drop downs, on-off switches, because we can do more than just click switches and fire off custom events. We can also pass data or variables or parameters as we fire these events. For instance, if we're doing an election graphic, we might want to be able to type the name of a state or a delegate or a number to show a percentage or result and pass that to, let's say, a bar graph in our AR scene instead of just clicking a button that triggers a pre-recorded action. For now, though, all we have are pre-recorded actions. So I'm just going to add a bunch of different triggers. We're going to have our enter exit logic, as well as our 3 different taunts. Let's go ahead and add a few labels as well, so we can identify what these sections are. And now that I'm pretty happy with the layout, let's just pull it up so this can be using as little space as possible. It's nice for a control panel to be easily readable, but it's also nice for it to be compact. This is going to be enter/exit. That is a very gnarly looking text color. I didn't mean to do that. I was actually going to set the background. And this is going to be fonts. Let's make that a bit more flamboyant. Let's make it an aggressive purple. There we go. That's a nice color. We can also use images if we would like to do that. So we can actually, instead of having a label, which is just a gray background, we can use an image file instead. Then we are going to populate all of these triggers by just pointing them at actions within the blueprint. And those are the actions that we just created within the blueprint we just made. So we're going to have enter. Target is going to be, well, the artist told me that the character was called Sparrow. So I'm just going to search for Sparrow. And there we see BP Sparrow session 2. Name conventions are important because I could also just search for blueprint, which we know is the correct name convention in our office. And now we can see all the blueprints within our scene. I can see that it's probably going to be this character, which has a name that rings a bell. And clicking this gives me an overview of all the different functions within this blueprint. Now there's a lot of different things here. Let's say I didn't make this blueprint. I don't really know what I'm looking for. But I know that the artists, since they're always following our style guide, they're always going to use the correct prefix. So I'm just going to search for PX. And now we see all the different events we just made. So we can see we're going to make a button for enter. Let's make that a nice green color. Next one is going to be, I don't know what the next one is because I didn't make the blueprint, so I don't know what the functions are. I'm just going to search for PX. You can see that there seems to be an exit function, so I'm just going to make a button for that as well. Being exit, I believe that probably should be red. And we can keep going and populating our buttons this way. Just about done here. Something that's also worth mentioning is the fact that a single trigger can do more than just trigger a single action. If the custom event was set to receive a variable, like maybe a number or a string or some kind of data, we could easily type in a pre-programmed bit of data. For instance, if we have a blueprint for election graphics where we can pipe in predefined names, then we could make different triggers that all of them have a pre-programmed name string, just so we have a single button that automatically changes, for instance, a state to Arizona or a color palette from Republican to Democrat to Independent. We can actually showcase this right now because if we try to go into, let's say, one of these taunts before we have gone into the idle pose, the taunt will do nothing. Because if you remember the animation blueprint, we start sort of idle invisible. We go from there to our idle loop. And from there, we're able to branch into our handstand, our bow animation, as well as our bow balancing animation. So we could say that I want this particular button to come hell or high water. I want to immediately go to the handstand pose as fast as possible. So I'm going to say that I'm also going to trigger our enter animation just to ensure that if this button is clicked, if we haven't entered already, we are first going to enter our character and then go directly into our handstand. You can have any number of targets connected to a single button as well. And here you could also set values, but there's no input parameter for this checkbox, so it doesn't really make sense to set a value right now. And there we have it. We have now created a control panel. I could operate this from this interface, or I can, of course, just operate this from any browser-based device on the local network. If you are on the same network as Pixel Director, you'll be able to access the same control widgets that you just created. So let's play around with this. Let's first try to trigger our bow animation. I also realized I forgot to name my handstand. Let's go ahead and fix that before we do anything else, just because it's an eyesore to look at. There we go. Apply, save. And then we just refresh our control panel, and there we go. So let's say I trigger here my bow balance. Nothing happens because we haven't entered the character yet. If I trigger enter, we unhide the character, she comes in, we go through the animation blend into idle. The moment idle is done, she will now do her taunt because it's already been checked. We are already waiting to go into the pose. We just weren't in the right state yet. The ceiling here is a bit too low for her to be doing that. And then at the end, we can now do our exit. Feel free to move the camera a bit if you like. Again, we didn't set hide, any kind of hide logic at the end there. Sorry about that. Now the handstand is going to trigger enter and go directly into handstand at the push of a single button, as you can see here. Click in, we go into enter, we do the same idle pose, and then we immediately go into our handstand, and then back to our idle. And that is more or less how you do AR within Pixitope. I think this has it went a bit longer than I was planning. I'm sorry about that. We still have a Q&A session, so I hope all of you decide to stay tuned for that. We are going to do a quick 5-minute intermission. So we have time to go get some water, do a toilet break, and then when we all come back at 7:48, we are going to reconvene and go through all your questions. So until then, I'll be seeing all of you in 5 minutes. All right, it is now 7:48. I'm going to give you 30 seconds to call back your friends and family and probably colleagues as well. And then we're going to dive into all your excellent questions and I will answer them to the best of my ability. I also luckily have a few colleagues who are helping out, so we should be able to get through all of these in a timely fashion. Okay, I think we are more or less ready to begin. So, first question is, can you edit a lens file or do you have to add a new one? All the lens files we are using within Pixeltope, which as we covered earlier, that's the lens file you select from your tracking setup here. Setup, tracking, lens tracking, you choose a lens file. All the lens files we use are saved in our CTS format. It's a plain text file, so it's very easily readable. The files can be edited and modified, and we also do have a lens calibration tool allowing you to more easily adjust your files on the fly. Next question is, how do you import a lens file into Pixeltope? Importing custom lens files, if you already have a custom lens file calibrated or set up to be used by a different virtual production solution, you can use it in Pixeltope, but you have to send it for us for conversion. It's generally a very painless, streamlined process. You just have to reach out and have us do the conversion for you. Next question is, same question, how do you import a lens file into Pixeltope? For all tracking systems that provide lens data and distortions, we would just use that from the data stream. This means that optical systems or tracking systems that give us the final tracking data, we don't really have to worry about using lens files. We only need to import a lens file into Pixeltope if we are using a mechanical tracking system, in which case, hopefully, whoever set up that mechanical tracking system created a lens file for you, at which point you simply send it to us for conversion. You will get a CTS file back, and then you would just hit this drop down. Sorry, not this drop down. Here, you actually have to add it to the lens file path. Now, if I have anyone from engineering listening in, feel free to tell me where the file path is. But if in the meantime, I'm going to see if I remember where it is off the top of my head. Thank you. So it's going to be under C, the feature group, Pixeltope Suite, Tools, CTS for camera tracking server, lens files. So under installation, just go to the Pixeltope Suite, your tools, your camera tracking server, lens files, and you just dump your CTS file, which is, again is in plain text, directly into this folder, which is then going to make it available from this dropdown. I'm going to leave this up for a second so you can take a screenshot of this file path if you need it. It's also, of course, going to be, this is something you can find out in our documentation, allowing you to, as well as in the recording of this video, which should be, of this session, which should be out in the very near future. Okay, next question is, do the sync packets drift over time? I've had other systems where this drifts as time goes on, and I have to reset on occasion. The short answer to that is, generally speaking, no. The reason for that is we've tried to use different ways of matching up the sync between a tracking delay and video input delay. We no longer use what we used, I don't remember what we called them, but we basically at some point had two different stacks of packets, video frames and tracking data. And we would just be matching these up sort of on a first in, first out workflow. The problem here is that if you were to drop a tracking packet for some reason, the tracking stack would change. And now suddenly you'd be skipping a tracking packet and you would now be misaligned between your video and your tracking data. We no longer do this. We simply, how the current frame matching works is based on the buffer size. So as long as we are correctly receiving tracking and video packets, your sync should be good. Right now, if you are missing tracking data, I believe instead you might risk seeing a hitch, but you will not lose your sync. So you're absolutely correct. The synchronization of tracking packets do need to be carefully managed, but our system today is very robust in preserving timing. This also, of course, means that reliable network transmission is absolutely essential. Tracking packets must arrive on time. This is also why we strongly recommend that you, under general settings, use a dedicated network adapter for your Pixeltope and tracking setup. Please do not use the same local area network as everybody else in the building is using, because the moment Jim Bob over in accounting starts torrenting The Walking Dead, suddenly your tracking packets starts arriving all over the place and your production happening in Studio 3 is going to have a very bad time. Next question is, let's see here, really is there a video delay? It's not being done externally. I'm not 100% sure what you mean by that, but we can cover the video delay. This last delay field is simply if for some reason we wish to delay the final composite out of Pixeltope, then you can do that here, which is basically just going to delay the final composite output. Generally speaking, we do want the delay from the Pixeltope system to be as small as possible. So in most use cases, you will want to leave this at 0. But if for some reason someone like a director comes and asks you if you can delay the composite from your system, for instance, if you just need to quickly try to match the video or the composite together with, say, audio for lip sync, then we do have a way of doing that from this interface. Next question is, what is the convert to shadow catcher exactly doing? The only thing convert to shadow catcher does is it changes the custom depth stencil value of that particular actor. We can actually show that right now by jumping back into our level. Some of these conversions, like converting to, say, a holdout, I believe, will change the actual material. Same if we convert to transparency. But most of these conversions will just change the depth stencil value. As you can see here, if I pull in a cube, in the details tab for this cube, I search for stencil. The current custom depth stencil value is 1. If I right-click it and convert it to a shadow and reflection catcher, the depth stencil value is now 2, and the behavior of this cube changes in our composite. Which you can see if I convert back to foreground. It's visible in our final composite output. That'll be that way. Converted to a shadow and reflection catcher, and now it changes the composite behavior. Technically speaking, you don't even have to do this right-click. You could literally just change the values directly here. But that is, of course, going to require a bit of memorization of what the different depth stencil values are, which is why we have the right-click menu in the first place. Okay, so our next question is, let's just bring in our character again. There we go. Next question is, my internet skipped at the moment you selected holdout for the boxes. Could you describe how you did this again? All I did was right-click and convert those boxes to holdout. I also made cubes. I measured the physical boxes on the floor. I made a cube with the same dimensions, and I positioned those cubes in the correct position on the floor so they were overlapping perfectly. If you would like to see this done again, you will be able to access the recording in the very near future, so you can review these steps at your own leisure. The next question is, are there any particular recommended workflows for generating accurate meshes for holdouts? There's very many optimizations available. Depending on the complexity of your geometry, from if it's just like a box or a simple blocky shape like a typical talent desk in a studio, you might be able to just go out with a ruling tape, measure the different dimensions, and model it manually in a 3D modeling suite of your choice, Cinema 4D, Blender, Maya, Max, Modo, whatever. If it's a more complex geometry, like the chair we are using here, or maybe a giant environment like a football stadium, then you might want to be using photogrammetry or a LiDAR scan instead. There's lots of guides on how to do this reconstruction from photos available online. The keyword you would like to keep in mind is photogrammetry. Next question is, can you easily edit the lens file, or do you have to add a new one to the list? Editing lens files is possible, but it's not entirely trivial. It's a pretty complicated subject. There's no interface for doing it currently within the Pixitope interface, whether editor or director. New ones can be added to the list using the way we just showcased based on the earlier question, and that will make these new lens files appear in the tracking panel here. We do also have a lens calibration tool, but given that that's not been listed here, I'm not sure if that's currently rolled out with our public release of Pixitope. In regards to creating a perfect lens file, well, in order to have perfect tracking and perfect distortion, lens files should be calibrated and stored based on the unique serial number. I'm not sure what you mean by that. Basically, you will need a unique lens file for that particular lens. Even if you have two lenses which are the same make from the same manufacturer, they are still going to require a unique lens files because there's not two identical physical lenses in the world. Microscopic imperfections in the glass in the different lenses is going to cause different distortions, meaning that you need to calibrate every single lens you intend to use in production in order to have good lens distortion. This is not unique for Pixitope. This is the same across every virtual production solution you're going to use. We can help with some template lens calibrations that will give representative calibration for that make and model of lenses, because we are slowly but steadily building a library of different lens makes and different lens models. And you can then modify that template to more closely match your specific lens with the specific oddities and imperfections of your lens in your studio. That got a bit verbose, but I hope that made sense. Next question is, that has already been answered. Do the sync packets drift over time? Yes. Next question is, if I make a makeshift virtual camera setup in a real blueprint, can I use it as a tracking system within Pixitope? No, but I think I understand what you're trying to do, and you could do that in a different way. Instead of using a tracking system, which is a tracking system, you can instead use manual tracking, allowing you to no longer use tracking data. We can see that the tracking immediately shifted. Instead, we can go here into the tracking panel, and we can feed in fake tracking data from the tracking calibration panel. So now, instead of using actual live tracking data, I can instead go ahead and offset my camera with this fake tracking data using the director interface, which means I no longer need to be using a physical tracking system. This is very handy if, for instance, you're trying to evaluate Pixitope and you have a studio camera but you don't have a tracking system, at which point you could just lock off your camera and you could use measurements to feed in here under manual tracking to align your non-tracked, let's say a tripod camera, with the virtual camera within Pixitope. Very useful stuff. Let me just quickly change this back to our MOSI system before we go on to the next question. Hey, where's my tracking data? Oh, that's a bit unfortunate. Go. Do you happen to remember these values as well? I believe it's minus 15 and do you have these noted down?
No, it's 10. X is 10 plus.
This is 10?
Yeah, A is 118.
Oh, yes, of course.
And there's 21.
21. Thank you. Sorry about that. You should always, of course, note down your offsets and your values if you intend to click random buttons like I'm doing right now. The next question is Vive trackers and virtual controllers. There are many solutions online to use this for tracking. I'm wondering if they can be used in Pixeltope as a tracking source, and the same question applies for video capture. If I have a capture card that works in Unreal, can I use it as my video source? The functionality is there. We do have Unreal Engine 4 virtual reality capabilities. It's currently untested by us. We've done some fiddling around, but it should work on paper. We also currently only support the Aja line of cards, but we will support NDI in the near future. What you can do in terms of video capture is, of course, record your screen for now using something like OBS. As for input, you can also play back pre-recorded video input using a tape deck or any kind of SDI playback device. In regards to more in-depth regarding Vive trackers and these Vera controllers, I have actually been on productions where these have been used. The tracking from the Vive system went through a third-party tracking solution. I don't remember off the top of my head. I believe it might have been OptiTrack or SolidTrack, but I'm not going to say for sure, so don't quote me on that. But if you find a system that facilitates this, ideally a system that passes this data along as 3D, which is sort of a universal way of tracking protocol, then you should easily be able to use this within Pixeltope. So that is going to be a bit of a science project on your end. But if you do that, please let us know how it went. Next question. Let's see, that's the same question again. Just more in detail regarding video capture. Pixeltope does have its own video pipeline in order to protect and preserve the quality of the video image of our final composite output, as well as our input video for that matter. So we have our own video I/O subsystem that works with Aja video cards, the Kona 4, the Kona 5, the Corvid 44, the Corvid 88, and the I/O 4K. Let's see, next one is going to be, how do I tell Director to use my makeshift tracker? I suspect this ties into the Vive question just answered, so I hope that is satisfactory. If not, please reach out at a later point in time if I misunderstood your question. Let's see, next one is more of a statement. It's awesome to hear about NDI as an input that opens the door to a lot of solutions. You're absolutely correct, and I personally think that's really exciting too, as does the rest of my team. Next question is, what's the shortcut to snap objects to the floor, as you saw me do earlier? That's going to be the N key on your keyboard. That basically takes your geometry and moves it down until it collides with a different geometry within Unreal. If that doesn't work, that is possibly because the floor geometry doesn't have a collision mesh or Unreal fails to detect the collision. So if nothing happens, you will sadly have to do this manually. We can take a quick look at that right now, actually. So here I have a cube. And if I now go ahead and use my keyboard to hit end, the wire wasn't very long and I've just spilled coffee everywhere, but that's fine. The show must go on. At end, you can see it snaps my cube down to the floor. But let me just get the most expensive equipment out of the way of this critical coffee leak, and now move on. Another way of snapping things to the floor, which I like to use if end for some reason does not function, is moving the pivot of my geometry. This is especially useful if you, let's say that you're using a different shape, which is a bit more complex, like let's say this chair. Let me get a copy of this chair over here. Let's say the pivot is not on the floor, the pivot is at some random corner because whoever made this don't know about bounding boxes and 0 points. You can use the middle mouse button on your mouse to move the pivot. and you can hold the V to snap this to any particular vertex. Like I'm doing here, I'm snapping it to the lowest vertex on this foot. You can right click, you can go to pivot, and you can set as pivot offset. The next thing you can then do is, now that the pivot is on the floor, we can just find a vertex on the floor. For instance, this corner vertex over here. And we could, for instance, simply grab this object. Let's see if we can shuffle this over here. And snap it to the vertex of this particular plane. So I just move this, I hold V to snap, and it snaps to this vertex. And now our object is guaranteed to be on the floor. This can be a bit more finicky and time-taking. Personally, I tend to eyeball it. I will use the snap to vertex to snap my pivot to the lowest vertex available on the model, like for instance the corner, like here. Then I'll simply move it on down. See, don't do me like this. Until I see that the white ball, which is the center of the gizmo, is halfway below ground. Let me just go ahead and zoom in. As you can see, it's now halfway to the ground, which means this object is on the ground with sub-millimeter accuracy, which should be good enough for pretty much every use case, unless you're using a 1000mm telelens in some kind of crazy microscopic production. Next question is, I think you're talking about a visual preview on the screen we can't see. That was asked a while ago. The preview you should be seeing has always been on this either side of me as a separate webcam feed. If you weren't able to see it, then hopefully you'll be able to see it in the recording that's going to come online a while after the seminar ends. Let's see, next question is, how do you know that the packet delay is, basically, how do you know that your tracking data delay is correct or how do you know if the delay for tracking needs to be different from your video? This has to be done with a visual test. It's very rare that you need the same delay on the video and the tracking. The way you test this is by using snap zooms and snap pans to check your sync. So here again, I'm intentionally breaking my tracking video delay. I'm going to ask my operator to just do some snap pans. And here we can see that now the tracking data is lagging behind because the video is moving first. And then as the operator keeps moving the camera, could you change this feed to be the video output feed? I believe this might be why they're asking, because they're not actually seeing the video out. There we go. So now as I keep offsetting these packets, I keep looking at my composite. We keep moving the camera. And once everything looks like they're moving at the same pace, that means we have achieved sync. And that is more or less the process. It has to be based on what you're seeing through the camera. Let's see. Next question is, can you scale the size of the labels? I'm assuming by label, you mean these little widgets. The answer to that is yes. You can select any actor which has a widget like this light source here. To search for billboard underneath object details, you can easily adjust the billboard scale. Perfect. Oh yes, sorry. This probably is not the widget you're talking about, is it? You're talking about the control panel widgets. And you can scale those as well. Let's go into Aspire Controller. We can go ahead and space things out a bit. We currently can't group things. You will have to move and scale things individually. It's worth mentioning that the control panel is still in its infancy. There's a lot of functionality which is going to be added to the control panel over the next versions of Pixeltope. So here we can see we can easily scale and offset and move things. I actually made things look a bit more gnarly, but that's just to quickly cover that question. Next question is, what are the benefits of adjusting your reflections globally instead of adjusting the roughness map in the material editor? Is one more taxing to the engine in comparison? The answer is no, it's not more taxing, but it's just nice having sort of a global override. Let's say, for instance, that your floor has multiple different surfaces which have different roughness. Maybe the left side of your studio, it has linoleum, which is very shiny, and then suddenly you have a carpet or wood, like a wood paneling, which is still shiny but less shiny. So you have two different roughness intensities, and you finally tune these to be just the way you want them. But suddenly a technical director or a producer comes in and asks you to just tone down the reflections because they're a bit distracting when certain effects happen. Then you could, of course, go in and adjust the materials on your different reflective surfaces, or you could just go into world settings and adjust the reflection intensity here. It's also worth mentioning that these reflections only pertain to the AR reflections, which means that if you're using the same material on an actor, which is just a normal AR element, then these sliders will not mess with the reflections on your AR object, as opposed to the shadow and reflection catcher. Next question is, can you set up an HDRI textures in Pixitope as a video or animated image? The answer is yes, but doing sort of a live refreshed HDRI feed is going to be a bit more difficult. I don't think we're going to cover this question in detail right now, but there's multiple ways you can use rapidly refreshing HDRI textures. For instance, using a live HDRI capture device, either externally or within Pixitope using a scene capture cube. It's worth mentioning that this is a very expensive operation. We don't typically tend to do it. If you would like to know how to use the scene capture cube to update an HDRI on the fly, please consult the official Unreal documentation. Just search for scene capture cube. This should hopefully also give you a pinpoint on how you would go about doing this with a video feed or a live feed instead of using an actor within Unreal. Next question is, are there any specific photogrammetry softwares your team uses and would recommend to use? I'm sadly no authority on that particular question, but we can see about having someone from our creative team reach out and talk more about what we tend to use for our photogrammetry sessions. What kind of capture card are we using? We are here using, I thought we were using an Ajakona 5, but I see it's been answered here. We're using an Ajakona 4. Let's consult Aja control panel. Doesn't seem to behave today. Do you know which card we're using?
Check device manager, but I'm pretty sure it's
Okay. So I'm being overruled. I believe it's actually a Kona 4 in this machine, but we do support Kona 5 as well. Next question is, with some camera tracking solutions, one can stream lens information into their virtual productions. Is this functionality available should the user select the correct camera tracking mechanism? I believe you're talking about, for instance, depth data from the NCAM tracking system. Let me check. No, sorry, you're just talking about simply the lens information as in the field of view and the final decoded defocus values. And the answer is yes, and that's actually preferable. This is very typical from optical tracking systems like the Moses Star Tracker or the Stipe Red Spy, as well as several other tracking systems. And this is absolutely what we prefer, because that means we don't have to worry about using lens files. We just get data, and if the tracking is set up correctly, the data should just work. Especially if the tracking manufacturer has spent a bit of extra time properly calibrating their lens on their side, in their system, and that data is provided in their tracking data stream, allowing us to use that in our track camera within Pixitope. Next question is, do you have tools to help calibrate lenses? I believe that has not been answered here, so let us get back to you on that question. Earlier in the session, you exposed the intensity and temperature of one of your spotlights. Can you show where these exposed properties are accessible? These exposed properties are accessible from, for instance, the Adjust Object panel, where you can simply grab the light that we just adjusted. That was probably going to be the spotlight back. And these properties live underneath the list of properties in the Adjust Object panel. I could go ahead and go into this particular spotlight. We can expose something new, like go to Details panel. Let's expose the width and the height of the light. Now, if I just reread my scene, we can see that these new parameters are now exposed and added to this list of properties. You can see that the property has been exposed because it has a lovely golden star next to the property itself within the editor. Next question is, there's another question about the lens calibration tool. So I believe we probably will need to address all of this either in a later session or in some other way. I don't have that information currently available. Next question is, it's less of a question. It's I think we're all stuck at home, and this seems to be one of the only ways to play around. I'm sorry to hear that. I also am getting a bit homesick. I'm sorry, not homesick, but rather the direct opposite. We all get a bit of cabin fever over here in Norway. Next question is, are the objects in the touring scene imported into Unreal, or can you import and keep the reference alive so that if you were to say edit and resave your object, it will also update in the scene? The object in tour scene imported into Unreal. I'm really sorry, but I'm not 100% sure what you mean here. But if you update a geometry, for instance, if you created let's say the holdout for this chair, if this is something you blocked out in the 3D modeling suite and you update the geometry and you update the raw source file, then you can, from within the actor, as long as the source file, the path has not changed, then you can see that every geometry, texture, and actor that you import into Pixeldope and Unreal has a source file path, allowing you to easily re-import the geometry or the asset. If you're talking about offsetting and moving things using the Adjust Object panel as a transform or adjusting parameters, these are saved in the scene as adjustments, and then we simply choose whether you want to bake or remove these adjustments to either save them permanently or remove them from this scene. You can see that baked, which slightly moved Sparrow, which means that I had a slight offset that I didn't have baked down already. I think at this point we are going to wrap up the Q&A session because it's sadly getting very late over here. We're very happy to see that so many of you decided to stick around for as long as you did. And I think we're going to call it a day. Before we wrap this up, next session tomorrow is going to be covered by my dear colleague Jonas Bexan, a very talented and experienced Unreal and Pixeldope artist. It's going to be an overview of Virtual Studios, how to build beautiful virtual sets, how to use all the Pixeldope specific actors to enhance your virtual sets and set up the proper composite to ingest your green screen talent. He is also going to be covering set transitions, both by replacing or streaming levels, as well as using virtual camera moves, as well as how you could combine AR and Virtual Studio in a single level and what that means for your virtual production capabilities. I think that's going to be it from us today. Thank you for sticking around, and we're hoping to see all of you again tomorrow. Thank you.